Dr. Søberg, welcome to the podcast. It's a pleasure to have you here. There is a cold therapy, winter swimming revolution that's really taking place right now. And anybody who's on the web, social media, sees it firsthand. And your work and research is a huge part of that. And your advocacy too, that's there, of making this more accessible. So first and foremost, thank you for being here. Thank you for your work. I'd love to start off big picture, because there's a lot of people here that still don't know the benefits and the power of cold immersion, cold exposure, winter swimming. So can you start off with, we'll get into the long-term benefits next, but talk about some of the short-term benefits that come from exposing our body to an uncomfortable level of cold.
Yeah, thank you for having me also, Dhru, here. I am so excited to be here talking to you about the cold as a first thing. I think that it's a really good question. What do we get out of doing deliberate cold exposure? So as an acute thing. So what do we get out of it immediately after submerging into the cold water? And I think that the short-term benefits are amazing. They're going to show up and have long-term benefits too, but the short-term benefits is amazing. So when you submerge into cold water, you will have an activation of your sympathetic nervous system, but also your parasympathetic nervous system, which means that you will have an increase in norepinephrine, dopamine in your brain, and that's going to make you more focused, give you drive and energy, which you can take out and use that for the rest of your day. So that's a really good thing if you also want to just have more energy and you want to be more driven to something, and you will use that without really forcing it. It's just there, just submerging yourself into cold water. So that's amazing.
Just one thing on that is that I think that we've done a lot of episodes here with different experts on the brain or relaxation techniques and meditation. And most people know about the power of, stimulating our bodies rest and relax, right? But we forget about the power of targeted stresses. And really what I'm hearing you say with cold immersion and cold exposure is you're kind of doing both, right? Which people don't often think of that as being good, but you're explaining to us that there are benefits that come from doing that in the short term, like that you feel pretty much right away.
Yeah, exactly. And that is what I also called stress up to stress down. So you stress yourself immediately as you go into the cold water, but you do that for, you're stressed for a very short amount of time, and you can use your breath to lower that stress. And that's kind of like a mental challenge in itself. So you would need to overcome this stressor. And with that, you widen your window for stress by doing so. And this is actually something that we need in this society, where we have this very narrow window for stress. And it's not like we are not too stressed and we don't have too much to do. We of course do, but we also need to adapt to that and find a way to get through this without having too much stress in our body. And that is what's causing all these chronic diseases, and we are getting more sedentary and we are not moving enough. So this way of increasing our stress threshold and widen our windows for stress is something that the cold can help us with. So it has a lot of benefits, not only immediately in your the physiological level of benefits, but it also have mental benefits. But it also has something to do what you can use for throughout the day. So it's a higher stress threshold.
When I do cold immersion first thing in the morning, and I have a cold bath that I had for a little while, but sometimes I'll also do, cryotherapy, which, we'll talk about the different versions. That's not always accessible to a lot of people, but I immediately feel this boost in mental clarity. It feels as if I had an espresso, but without sort of the crash that comes later on. What's going on there that you feel that sense of being alert, more focused, and kind of more jovial? You're just more excited about the day.
Yeah, exactly. Well, that is because of the neurotransmitters that is released in your brain, and it stays there for multiple hours afterwards. So when you submerge into cold water, studies already done in the 1970s show that you increase norepinephrine up to 2.5 folds, and it could actually be more. In some people, it's actually more than that, which is a huge increase in the energy you will get out of that. And it's also an increase in the dopamine by 2.5 fold. So you will have this high increase of energy, and you will have a drive, and it's also something that definitely will wake you up. So instead of drinking maybe a cups of coffee like you do, you can just go into the cold water instead and have that quick awakening and have that energy afterwards. So it's definitely better, I would say.
Well, the other thing too is that, obviously there's a lot of benefits that come with coffee, if people are making it right without like all the sugar all the time, kind of how we do in America. Yeah. But you can also do a little bit of both. You can have a little less coffee is what I've found. Not that I ever was like, drinking 5 cups a day or anything, but I'll typically have a cup, but I don't feel like I'm reaching for that second cup because I have the natural boost that comes from that cold immersion. What do you think are some of the reasons, like what's going inside the body that the response to this stressful situation is to create something like dopamine? Like why would our body be doing that? What does it think is going on when we are exposing ourselves to, cold water is primarily what we're going to be talking about over here, cold submersion, being submerged under the neck. Why would our body be putting out dopamine, for example?
Well, when you submerge into cold water up to the neck, you would have an activation of your fight and flight response. So that is the body trying to escape from this stressor, this toxic thing that is actually going on. It thinks that you are doing something that is going to kill you. And if you think about it, that is actually also very dangerous to the body if you stayed there. So the body prepares itself to save you. And by doing so, the body increases your stress response. So dopamine is a stress neurotransmitter and hormone. So it's going to increase very rapidly to make you escape this very dangerous situation. And so also norepinephrine.
Adaptation.
Adaptation. It's adaptation. It will create adaptation on the long term. Already after 3 plunges, studies have shown that you already get adapted to this. So the body recognizes this situation and prepares itself. This is a process that happens in the cells where the cells increase heat shock proteins and also prepares itself for getting stronger. So resilience in the cells and also resilience just systemically. But if you do this for the first time, you will feel quite much pain, actually. So it's painful doing the first plunge. I don't know if you remember yours, but I remember mine. And it was really painful. So physically, but also a bit mentally, because I was so anxious about this, but also it was everything in my body told me to escape this. So dopamine, norepinephrine, and adrenaline, cortisol is increasing, and that is to save you, because this is a dangerous situation potentially if you didn't do it deliberately.
Right, and there are some situations where it can be dangerous, but your body feels it's dangerous.
Exactly.
But generally, cold therapy, cold immersion is relatively going to be safe. There are some precautions that we'll get into a little bit later on. And I think that your work is really helping people understand that, some of the fears that people have. So on one sense, cold, nobody wants to go out of their way to get cold, but actually you adapt through practicing cold immersion and cold therapy. You kind of start to look forward to it. Like that's where I feel right now, right? Like I typically would do my cold immersion before I came here, and I was running a little bit late, so I didn't have the time to, and I was like really missing it. Like I was really missing it before, because it gets me so excited and sort
energized.
Of awake before a podcast, which these podcasts go, 2 hours, 3 hours. So you need that energy to be there. But on the flip side, there's been press that's out there that is almost fear-mongering a little bit, cold exposure, right? We'll talk about that later on, but that people have overblown the fears that come with cold exposure, right? As long as you're doing it safely, you're not going to run into those, those concerns that people are worried about. But I'll get back to that in a second. So you mentioned something that the first time you did cold exposure, it was a shock for you. And in your book, you're right. You say, if a popsicle like me can learn to winter swim, which is, what you're also calling cold immersion, anyone can. It's a question of mindset. Here you talk about being a popsicle. I've also heard you in other interviews refer to yourself as being a little bit of a cold sissy.
Yeah.
So I'd like to talk about that before we get into the long-term benefits. There are people that are listening, and I wonder anecdotally, sometimes it feels like I hear more from women, but I'd love to get your thoughts on that. There are people that feel cold is not for me. I already feel so cold on a daily basis. Why am I going to go seek out cold? What do you want to say to those individuals?
Well, I want to say that I think that I represent most people afraid of the cold, actually. And we are very afraid of the cold in this society and the modern lifestyle as it is right now, because we've been escaping the cold for decades now. And it has not been put forward as anything that we should seek out. So if we go back to my grandparents, for example, they slept in the cold in their I think at 19 degrees was actually pretty cold, and that's what they did, and they told us to do this.
Which is about 65 degrees, 60 something around there?
Yeah, 66.
66,
yes.
Okay, great.
So they told us to do this, but that was already when I was a child. I was listening to that, and I was like, oh, that's really weird. Why should we do that? They told me this is healthy. This is healthy for you, but they couldn't explain why. Right. So this kind of died out a bit, and our society gets more and more sedentary. So the cold has been something that we forgot a bit. But I think that I, just like anybody else, like it very temperature neutral. And when I started this research, I was a cold sissy, as I already told in another interview. So I was pretty much like anybody else, not wanting to go into the cold, and why should I do that? Because it's just too cold. But I found out during my own research journey, but also from having to try this out myself, because I couldn't write a book and I couldn't do this research without really seeking this out in some way, because you can read and you can try and understand what it means to go into the cold and feel and try to understand the feelings of this. How does it feel on your body getting adapted to this? But you don't understand it unless you try. And what I realized was that one thing, it's healthy and it's not dangerous if you do it deliberately. That's one thing. And I found out that I actually get warmer. And at the point where I started doing my cold immersions, this was not proven yet. I did that in my research a couple of years later, but
yeah, you found the mechanism of what was going on behind the reason that, regular cold exposure actually makes you warmer in the long term.
It makes you warmer in the long term, and this has everything to do with your metabolism and what is called the healthy brown fat, and we can get back to that. But that was my research area. But what we saw, or what I felt, was that for every time I went into the cold water, I could faster heat myself up. And I was at this time doing field research, I called it, because I spent a whole year just observing winter swimmers in Denmark on different jetties or around the country. And I started doing this myself to see what happens, because a researcher also needs to understand it on her own body, I thought. So, but I felt that when I went home and I just kept moving, that I could feel that I was increasing my heat, and the time where from going up from the cold water to reheating my body, that window got just shorter and shorter. And at certain time, actually, I was warm before I got home. So I found out that this mechanism must have everything to do with my research area, which is the brown fat, so which is heating you up. And I was just thinking, oh God, my brown fat is getting better, increasing my heat.
Right, and that's a good thing. For those who are listening, brown fat is a good thing. We're going to break it down.
Yeah.
We pulled up some nice images from your book, which we'll get into a little bit later on. And but in addition to just becoming more resilient to the cold, right, which is one of the benefits of cold exposure, there's actually an incredible laundry list of long-term benefits that are there. And I'd love to start off by talking about some of those, because I've found, especially for my audience, is that when you talk about the benefits and what's possible and how we can improve our life, that makes us more excited to actually want to do the protocols and integrate them into our routines. So can we talk a little bit about, you talked about some of the short-term benefits, an immediate sort of improvement in mood, the dopamine hit that you get, which also doesn't lead to an immediate dopamine crash. It's sort of a long, gentle sort of slowdown of dopamine, which is exactly what we want. From shopping, from social media, we get these quick dopamine hits and they go away and we get a dopamine crash.
Yeah.
And we want to avoid those type of dopamine releases. We want more of the dopamine release that comes with cold exposure. So let's talk about some of the long-term benefits. Can you chat about that?
Yeah, so some of the long-term benefits. So I would just like to start with my own research, because that is like,
please, let's
do it. It's in adapted winter swimmers. So I recruited winter swimmers who were have been winter swimming for 2 to 3 seasons. So I wanted to study those because I wanted to see what happens when you have done this for a while. And this was also kind of a proof of concept study, because there was no other studies about this brown fat and how do we increase our calorie burning in our body and the metabolism. So we needed this kind of study where we just explored those who have been doing this for a while, so we could look at the long-term benefits. Does it really matter on the long term? And what we found was that winter swimmers who have been doing winter swimming for a couple of years, so 2-3 seasons, they have an increased brown fat activity, meaning that they can burn fat and sugar from the bloodstream faster than the control group. We saw that 11 minutes per week was actually enough. So I also seeked out to see if I could find the lowest threshold.
Yes, that's the minimum viable dose.
Yes,
11
exactly.
minutes a week.
Yeah.
For those that are listening. And that can either come from, one longer session, but usually it's typically multiple smaller sessions.
Yeah,
because
I would
when
say
you get
smaller
colder,
sessions.
you can only stay in there a little bit longer.
Yeah.
But we'll break that whole protocol down.
Let's do that
a little bit later on.
Yeah. But what we saw was that they also had an increased insulin sensitivity, and that they get rid of the sugar faster in the bloodstream, so they have an increased metabolism. They had a lower blood pressure, but this is not only shown in my studies. This has been shown in multiple studies in winter swimmers, cold water immersion studies, that on the long term, after actually just one winter swimming season, you will have a lower blood pressure and lower heart rate at baseline. So this really shows that these are really good outcomes to measure on the long-term benefits, because a lower blood pressure means that you have less inflammation. And this is come down to the root cause of all our modern lifestyle diseases. So if we can lower our inflammation in the body, then we have a good recipe to actually decrease and prevent lifestyle diseases. So that is really what I wanted to do in my studies, but that is also what other studies have found. So this all together really shows that we can decrease inflammation and we can decrease stress in our body. And I think if we can do that, then this has really potential for human health in the future.
Yeah, it's so exciting, and all the markers that you guys measured inside of the study. We'll get into a little bit of the background of how that study came together, and you had a mentor that was involved and kind of an advisor who was steering you in that direction. We'll talk more about that. But before we go there, I want to jump into a little bit of a time machine and kind of go back in time, because evolutionarily, our ancestors, even in recent history, they knew the power of cold immersion. And that's a big thing that I got from your book, is going down that history. So talk to us a little bit about that history. What did some of our ancestors, including Socrates, the father of modern medicine, well, not modern medicine, but medicine.
Ancient medicine.
Yeah. What were they saying about cold exposure?
Yeah, so I really think that was an area I needed to go down that path to understand what actually happened. Why are we so afraid of the cold today? So with that question, it kind of led me down the road to see what happened. Why did we stop exposing ourselves to the cold? And that led me down the road to our ancient philosophers of Socrates and Hippocrates, which showed that back then they had this, you can call it maybe an intuition to what is actually healthy for our body regarding the cold and the heat. But they said that going into the cold, but also heat, so cold water and warm water, actually increased our body fluid in our body. So that is what we know today is from increased circulation in our body, the ability to dilate and constrict our blood vessels, which you get from an increase in endothelial cells in our blood vessels. So today we can explain what actually happens in our body. What they back then intuitively said what was healthy is today now proven with science, and we of of course, need more proofs, but we do have enough today to say, well, it's actually something that is healthy for our body to go into the cold and the heat. And this is what the time was called the thermalism time. That is why my new book is called Thermalist. And they said that everybody should do this, and they did. So whole societies, you can see that from modern civilization, they built these cities around water, so around lakes and by the sea, and that is to expose themselves also to water just in general. And it also goes way back to our Egyptian times, where we can see that there are hieroglyphs showing swimming. So this is really something that has been practiced throughout times. But because of wars and also accidents with the Titanic, that actually gave a little bit of a dark shadow over cold exposure, because we then realized that, cold water is actually something that could also be dangerous for us. And because of the Titanic, and also because of World War II, and some human experiments that were performed in Germany, in Dachau, we kind of had this dark shadow over cold exposure, and research kind of stopped in this, because it was probably so popular to do this kind of research at this time. So people started saying that, cold water is dangerous and you can die if you fall into cold water, which is also true. But if you do it deliberately, which they said back in the thermalism time, Socrates and Hippocrates, then it's something completely different. So I'm glad that we picked it up by around 1970s, we started doing research in this again. And here we are 50 years later.
Years later.
Yeah.
And we were chatting a little bit before the podcast started. And, cold exposure and all the benefits that come along with it that you've highlighted in your research. And then we'll also talk about hot exposure, and especially sauna. And there's even a ton more benefits that are there that have been documented, because there's bigger studies and things that are there, but very similar pathways in the body that they activate. They're all part of this growing trend of people looking for low cost, no cost solutions to start to improve their health. And also this growing trend of people realizing we've sat too much, we're in front of the computer screen too much, we're indoors too much, and all this is making us sick as a society. Yeah. And going back to nature a little bit, not in a romanticized way. Nobody's out here advocating that we all need to move back into the woods and, fetch our own, water and cut our trees down. Although I'm sure some people would like that. It's more to make sure that we don't so far remove ourselves from nature that our body, which is based on millions of years of evolution, it needs those reminders to activate the pathways that it has inside, and activate our circadian rhythm as well too. I kind of want to ask you a little bit more about that. You talked a little bit about that in the beginning, this drive in our society for comfort, and this drive in our society to not be broken out too much of the equilibrium, and how much damage that's doing to us, and also the younger generation of kids that are growing into it, even to the degree that I find that parents are so worried about their kids, who actually have a little bit more brown fat naturally, going out into the cold, because they'll tell you, don't go out into the cold, you're going to get sick. I'm sure you've heard that before. Maybe a little bit less so in Denmark. Is that less of a thing in Denmark? People are a little bit more open to the cold over there?
I think so, yes.
Yeah. But in the US, I know for sure there's this trend of don't get too cold. Don't do anything that's dangerous for you. Right. And we kind of need to get back to these hormetic responses in our body to get back some of the benefits. Do you think that this is just a byproduct of industrialization? And when we started being able to have the heating of homes and the AC of homes, we just kind of got used to it because our cells are inherently a little lazy. Do you think that's where it came from?
Yeah, I really think that there is some truth in that. I think that, as I just touched upon before, that we kind of forgot what we need the cold and the heat for. I mean, extreme temperatures has been practiced so much before our modern society. So the last 50 years, we have kind of like forgotten about it. And also research has not been really focused on the healthy stress, which you just mentioned, the hormetic stress. So after World War II, we started researching a lot in the chronic stress, so the bad stress. And when you tell people, if you say the word stress to people, and people will be like, ooh, that's something really bad. So it's kind of like it's not people's fault that we don't know the good stress as well, but stress is not necessarily something bad. It's just what kind of stress you are exposed to, right? And what you let yourself be exposed to. So the chronic stress is something that research has been very focused on for many years, and it is the reason why we have the modern lifestyle diseases. But we have not been focused on how can the healthy stress, the hormetic stress, help us with the chronic stress. So that is kind of like the science world not being too focused on that since after World War II. So I think that it's good that we do that now, and we have more focus now. There's a trend growing in this, definitely, because that can keep us healthy, and that it is a low-cost way of repairing our cells in our body, which will then decrease the risk of chronic diseases like type 2 diabetes, but also mental neurological diseases as depression, which we know today has everything to do with inflammation as the root cause. So if we can, in this modern society, learn to understand that healthy stress is something that you can use and go into nature, not in a romantic way, as you said. It's not like that, but we can take parts that we know it's going to work for our benefit, and that will keep or help our body get into a balance. So homeostasis is our body's cells wanting to get into this balance. So our body is constantly trying to get into a balance. It is fighting this. Can we please get into balance? All our cells are calling for this. That's why we feel bad sometimes. That's why we feel sleepy sometimes, because we need more sleep, or we need more exercise. But our cells in our body, our fat cells, are calling for rest. Because if you look way back when we were living in nature, we didn't have our houses to sit and get thermoneutral in and relax. Then our body was always, you can say our body was always trying to rescue ourselves, and we were always in the fight and flight mode, probably a lot of the times. But we needed back then to rest also. But we probably today are resting too much. So we need to learn how to get back to that stage where we can increase our healthy stress in our cells and repair ourselves so it will get into balance again. So our body is trying to tell us something. That is why we get sick. That is why we get these inflammatory diseases down the road. So I definitely think that healthy stress is the way forward to help people in a natural way.
That's well said. I want to go back to something we said before, because most of my audience, I would say, probably a little bit over half, is women that listen to this podcast. And so is there any truth to the idea that women prefer not to get cold more than men? Is there anything in that, or is that just something anecdotally people pick up? Because I do hear from a lot when we've done other episodes with guests, I've heard more from my female audience saying that I, in particular, have a hard time. And my wife shares with me she doesn't like to get cold as much. But is there any truth to that scientifically, or is there not?
So I think that is a really good question, because I think there's two sides to this. So one thing you are addressing here is that women do feel colder faster than men, or at a lower degree. So they are also colder. So studies show that women have colder hands, colder ears, and also they're just colder on the feet, for example. And that is something that we can explain, because women have less muscle mass to keep them warm. So what keeps us warm in our body is two kind of tissues. That is firstly, the brown fat, which is always on a regulating state where it tries to regulate your body temperature from the inside. It's our inner radiator, you can say, what the brain is, the thermostat, you can say. And the muscles is the second tissue, which is keeping us warm. So, but we have less muscle mass than men have. So they are warmer just in general, and they are what we call thermocomfortable or thermocomfortable, I would say, at 24 degrees Celsius, which is in Fahrenheit. I'm just gonna 2 seconds. Okay, so 24 degrees Celsius is thermocomfortable for men, and 22 degrees Celsius is what scientifically is proven to be thermocomfortable for women. So 24 degrees Celsius for men, that is 75 degrees Fahrenheit, and 22 degrees for women is 71. So women do get easily cold than men, so they easily freeze, and that's why they say I'm cold, and men don't say that, and they try to turn the heater down at home, and the women are trying to turn the heater up, and this is the explanation behind that. But I also think that there is another question in what you just said before. So I think that my observation, I can only call this an observation, but because I don't think there's any studies on this, but I think women are doing more deliberate cold exposure than men are. I think that they are more interested in this, and that's probably because they also are cold, and they find out that they get warmer from going into the cold. I at least did, so I would say I would just keep going just to keep myself warm, and I get my brown fat going, and having an everyday life feeling warmer is definitely something that I can use. Also, it makes me less consider also going outside and use the nature, and I don't think much about am I cold or am I hot as I did years ago. So I think that women are actually seeking this, but they are generally from nature colder.
That's a great explanation. Thank you for that. You mentioned brown fat. I think this is a good opportunity to talk a little bit more in depth about brown fat and white fat. You have this great image in your book that I've put up on the screen here. And if it's okay, we can show the audience on YouTube. Yeah. And if you're watching the podcast, you can go on YouTube, you can check it out, or we'll provide a link inside of there, or just pick up a copy of the book, Winter Swimming. We have the link in the show notes, and you can find all of that and other great storytelling and the behind the scenes of how you came up with your research, what you found, et cetera, et cetera. So let's zoom out big picture. Many people actually don't know that there's different types of fats in our body. There's the white fat, the brown fat, but there's also the beige fat, which you talk about a little bit, the beiging of fat, which we'll mention. And tell us the role of these different fats inside of the body. So the fat that people typically look at or see that they have a little bit of extra fat on their stomach, what are they noticing there? What type of fat is that?
So that is the white fat. The white fat is what we have on our stomach and our thighs, and often we have too much of it in our modern lifestyle. We are too sedentary. So these cells, they grow, they get bigger, so we get obese. And this kind of fat we want to get rid of. We just want to get less of it at least. We need some because this is our energy storage also. So it provides us energy when we are not eating. So of course we need a little storage of white fat. So white fat is the energy storing capacity in our body, and the brown fat is quite opposite. That is our brown fat is our healthy kind of fat that is increasing our metabolism. So that is increasing the calorie burning of the white fat. So the brown fat can actually burn the white fat. So if we can activate the brown fat, that's gonna take up glucose and fat from the fatty acids from the bloodstream, and that is gonna decrease then the white fat storage, of course, in the long run. That is not proven on the weight scale yet, but I think that's gonna come in the future. So they're quite opposite, the good fat and the bad fat, you can say. Yeah, and then there's the base fat. I'm just gonna say something about that because please. I think the base fat is very interesting. There's a lot of mice studies and rodent studies showing that if we expose animals to cold, this is going to increase the amount of brown fat that they have. So we can actually look at the brown fat as something like a plastic tissue that can grow. which is going to increase our energy calorie burning in our body, but it can also decrease. So you can get less of the brown fat if you are not exposing yourself to temperature changes. So this is kind of like a muscle. You should look at the brown fat as a muscle. So if you train it, and that is with the cold, or actually also the heat, you're going to activate it. You're going to tell the cells, well, we actually need to temperature regulate this body to survive. And then you will keep your brown fat cells. So use it or lose it, as I always say. That's the same for the muscle cells. So the brown fat also has a lot of mitochondria in the cells. And that is for increasing the energy expenditure. And that is what it has also in common with muscle cells. So in some way, the brown fat cells, or the brown fat organ in our body, looks a little bit like the muscles. So you should think about the brown fat as something you can train, something you can grow, and it can also decrease. So use your brown fat in a clever way, so you can have this energy burning mechanism going in your body when you're not even exercising. You just have to expose yourself to cold a couple of times a week, and then you have that one going for you even when you get home. So I think that this is a clever way of like using your biology to your own advantage.
Yeah, I've heard you say in previous interviews that we all know that strength training and going to the gym in a deliberate way is the way to increase stress, a good stress on the muscle.
Yeah.
And our muscles break down and they respond and they get stronger and they get bigger if we're eating protein as well too. And so the gym, which is stressful, it's tough to go there, especially the first time. The gym is to muscles as cold exposure is to brown fat. We have to think of our brown fat.
Yeah.
Again, I've heard you share before. You have to think about cold exposure is the lifting the weights for the brown fat.
Yes.
When I heard that, I was like, that is the perfect explanation that I could give to my wife, who, the crazy thing is she loves, shout out to Yasmin, who's my beautiful wife. She loves cold therapy when she does it.
Yeah.
But I don't think she did it consistent enough that she hit that threshold where now she looks forward to it. So it's always that thing you kind of feel like, oh, I don't want to do this. I don't want to do this. And you do it and you feel amazing afterwards. Yeah.
I think this is right on. Exactly. I call the cold your metabolism training center. So you go into the cold and you train your brown fat to increase and get better, more efficient. What we showed in my studies from 2021 was also that when you train your brown fat by going into the cold water, you get more efficient brown fat cells, and you will increase your thermogenesis in your body. So the warming capacity. But what is really interesting, I think, is that when you think about the brown fat and going into the cold, you can think about the temperature as your weights. So if you go into cold water that is like 2 degrees Celsius, which is 35 degrees Fahrenheit, then you can see that as a heavy weight, and you don't have to stay in the water that long. But if you go into water that is maybe 20 degrees Celsius, which is 68 degrees Fahrenheit, then you can stay there a little bit longer because it's a more lightweight. So use the cold as a training center for your metabolism and also for your mental health. So it works on so many levels. I think that it's something that we can use. Everybody should use it for some reason. There are so many reasons to do it. So, but metabolism is definitely one of the big things.
The primary reasons.
Yeah, I think so.
Especially in this day and age where not only are we sedentary, but we also have so much prevalence of ultra-processed foods, which comes with a concentration of calories. So we're sitting too much, we're overfed, and now white fat, which is this beautiful designed by evolution to be our energy center. It's like a battery pack. The same way that if your phone is running low, evolutionary, we didn't want to run out of energy. So our bodies got really good at putting on weight. It's just that now there's too much input and there's not enough output and proper stresses that are there. Your work was so groundbreaking because nobody had really seen this mechanism of brown fat being activated with the cold. And I want to zoom out. We'll come back to the work in a little bit and kind of how you designed it and how you kind of came up with it and some of the surveys that you did as well with the population on winter swimmers. But give us a little bit of the history of brown fat. I was reading a little bit that you wrote in some of your interviews. You were talking about that brown fat was really discovered in the 1500s, and we first noticed it in hibernating animals. Is that right?
Yes.
Can you talk a little bit more about that?
So the brown fat was discovered by this researcher his name is Conrad Gessner in 1551. He discovered this in an animal because he was very much looking into animals and also plants and discovered a lot of things. He's very famous. So, but he discovered the brown fat as this tissue which is very dark because there are many mitochondria in the cells, and he described it as a tissue which was not really white fat and was not really looking like the muscle cells, but something in between. And he described it as something that was in these hibernating animals, as something that we would need to increase our temperature when we are cold. So he discovered this, and later on, researchers found out that this was actually also in humans, and we found out that this was activated in humans, and babies have a lot of it. But we were thinking, or researchers were thinking, already in the 1920s that this was not something that we needed as an adult, because it decreases with age, apparently. So babies have a lot of brown fat, and more than adults do. So apparently it's really good for increasing your temperature in your body, but as the mass of your body grows, the tissue decreases in size. So it's definitely something that has everything to do with keeping the body warm. And a baby under 6 months cannot activate the muscle cells to shiver. So it needs a lot of brown fat to keep itself warm. And as soon as the baby gets a little bit cold on the skin, this will activate and keep it warm. So it's to survive, right? So, but we need to go up to 1980s when we started doing research again in the brown fat and discovered that this was also in humans and that we still have something left. And people were like asking, why do we have this? And researchers looked more into it and found out, well, they concluded it doesn't really have any purpose, which was really a shame. But then we came to millennium, and researchers found out that even people who are adults and also people over 40 have this brown fat tissue, but it decreases after 40 years of age, where BMI also increases. So that's kind of like not a really good thing. But what they realized was that when the brown fat is activated in humans, it increases our metabolism, and this was also proven in people with type 2 diabetes. So this was kind of groundbreaking from the millennium. Then people started doing research in brown fat. This was the new hot topic, you can say, in metabolism research, that people would like to find out, how can we activate the brown fat? How can this help this growing pandemic of obesity? So that is why we are here now, talking about this.
Yeah, and as you mentioned, brown fat is associated with less obesity. Typically, the more brown fat you have, the less obese you are as a person.
Yes.
Right?
Yeah.
And that, zooming out even a little bit more, is that, you were saying that it decreases after 40, but that also could be that we don't live in a world that is used to activating it, right? So it's not that you're inherently saying that, okay, everybody hits 40, it's kind of bad news from there. Just like muscle mass tends to decrease, in your 40s, 50s, 60s, and 70s. Well, we don't have a lot of examples of healthy people who at those ages still regularly go to the gym on a big population level, right? So it doesn't have to be that way, and we can do things. And that's really what your work and research is about. Now, getting to study brown fat and your groundbreaking research that you did on it, before that, you were interested in the topic of metabolism, and you were doing some work in that area. What were you doing in metabolism before you did some of this cold exposure research and seeing this mechanism of brown fat being activated?
Yeah, it's a really good question. How did I get into this? So way back, I was working in the hospital, in a hospital ward where we had a lot of really sick people, actually, cardiovascular diseases. So, and I was feeling that I was coming a little bit late to help people. So working there, and I love my job, but I did have this feeling of, why do people end up with all these blood clots in their legs and getting amputated, which they did in this hospital, so in this ward where I was working. And I was asking myself, what can we do? And I always had the question about how does this actually, what actually happens? Why do we get more and more inflamed in the body? And can we not look more into helping people before they get sick? So with that thought, I went back to university and studied a science master and a master in science, public health. Yeah. And during that master, I wanted to see if I could do some studies in some basic research into how we prevent diseases. So I started out with asking the question, so can we lower our degree of sweet tooth for snacking? And because if we can do that, then we would also have a helping hand to not have all this caloric intake, of course. And that is why I started doing research in what is called the FGF21, which is the fibroblast growth factor 21, a liver-derived hormone, which we, just to fast forward to our results from that, published in Cell Metabolism in 2017, which we found the genetic cause of the sweet tooth. That's how it ended up. It took some years to do that. But FGF21 showed, we found that if you have a variant on the FGF21 gene, then you would have more of a sweet tooth. So it's not something you can do anything about, of course. I'm genetically predisposed to having a sweet tooth, but it really showed that some people do have a sweet tooth more than others. And that was kind of like the start of my interest in preventive medicine. And then I went into the brown fat research because I wanted to do something that I could go out and make an application, say, well, you can applied research, it's called, right? So I could go out and say, please do this to keep yourself healthy. And that is why I went into the brown fat research. It was new and it was not very explored. And I think it's very interesting that you can do something natural like going into the cold or the heat and what actually happens in the body. Not that I was a winter swimmer myself, so it wasn't because I was fanatic or anything about that, on the contrary, actually. But I was interested to see how can we stay healthy naturally. So.
What was your first experience? You read about this a little bit in the intro, that you were saying that you and your husband were going on a walk in Denmark and you saw a group of winter swimmers. Was that before or after you had an advisor saying, you should look into this emerging sort of field of cold exposure? So what came first? Did you happen to stumble upon this group, or was this advisor kind of steering you in the direction, or did they happen at the same time?
No. So the observations with my husband on the winter swimmers in Denmark have been for years.
For years, you see them around.
I live close to the water, and when we go for a walk on the beach and people winter swim, and remember that I was not really a fan of the cold. I couldn't really see why should I go into the cold other than my grandparents told me to, but they didn't explain why, so I didn't want to do it. But we were kind of talking about it. Why would they do that? Of course, they're not insane, but they do it for some reason. It seems like they are having fun. And that was like stuck in my head. So they are doing something here. They claim for themselves to be healthy. That they can't explain it really, but for some reason they all agree. And I don't think they all gather one times a year and then explain to each other what are we going to go out and say. Of course, it's not a conspiracy in that way, but they all say the same. And I was kind of like fascinated by that. And then when I went into this brown fat research, that was kind of like my mentor saying, well, now you're done with your master. You published this in Cell Metabolism, FGF21. Maybe you should try something in the brown fat area. And Matthew Gillum, that was my supervisor at that time. He's associate professor at Copenhagen University, and he said, "Well, maybe you should look into this brown fat." And I got the job in this group where they examined the brown fat mostly in cell studies and in mice, and no one in the group really looked into the human studies. So I asked whether they would like to have human studies in this, and they would very much love to. And I read a lot of studies about the brown fat, and it took me months and months and months of reading, but I could see that you could expose yourself to the cold by sleeping in a cold room at 19 degrees Celsius, which is 66 degrees Fahrenheit, and that's going to activate your brown fat. So this was tested in subjects, obese subjects, and they slept for a month at 19 degrees Celsius, and then they could see that there was an increase in brown fat amount and also an increase in insulin sensitivity. So that was really interesting.
And just one clarification on that. Yeah. Sorry to interrupt.
That's fine.
So when you're in the room and you're sleeping at that temperature, and maybe you don't know, but maybe you do know, were the participants still had any kind of blanket on? Just the air temperature was at that 66 degrees?
Yeah, 66 degrees, but they had this duvet thing.
Okay, got it. So it wasn't just like the exposure to the air. They still were a little bit warm inside, but the air outside was colder.
Yeah, exactly. It's also because you have temperature receptors also in your mouth, in your lungs. So that's also going to be activated, and you also have that in your face and your hands. So you're going to be exposed to the cold, and the body senses this, and the brown fat will be activated just by that. So you will increase your metabolism just by sleeping in a 19 degrees room, which is 66 degrees Fahrenheit. This study was so amazing, and it really impressed me. I was like, wow. So you can sleep at 19 degrees and increase your metabolism just by sleeping there. And it increases your insulin sensitivity. That is amazing. And you don't have to take a pill. It's just sleeping there.
Right.
So I was just asking, because I live in Denmark and we do see a lot of winter swimming going on there. And this is 2016 at this time. So I was thinking, just for fun, well, what about people working outside? What about people who dips in cold water? Will they activate the brown fat? So this question led me to research the literature around winter swimming. And I found one study by Stormer et al. From 2016 showing that by winter swimming in middle-aged men and women, they increased their insulin sensitivity by one winter swimming season. But they didn't study the brown fat. And actually, in the conclusion, they write that they don't have an explanation for this increase in insulin sensitivity. So I connected these dots and thought, oh, wow, it could be that the brown fat is the missing link. And that is like the background for starting my research.
Wow, super fascinating. And you were talking about, insulin sensitivity. We've done so many episodes on this podcast about the important about staying insulin sensitive and not being insulin resistant, which is something we don't want. That's when the insulin can't get into our cells because there's too much of it. And many doctors and researchers have come on this podcast talking about how that could be playing a role in this inflammatory cascade that you were sharing a little bit earlier.
Yeah.
And food, of course, is one of those components that are there. Just too many calories, too much sugar, too much refined flours inside of our diet. So anything that we can do, it's not that we have to stay away from these foods altogether, but any other lifestyle things we can do, like working out when we build our muscle mass. Our muscles are one of the biggest consumers of glucose in the body. But what you're saying now and what you found through your research is that, hey, it's not just our muscles, it's our brown fat too. That can be something that can also end up utilizing a lot of this sort of free-floating sugar in the system and make us more insulin sensitive, which is a good thing. Is that correct?
I think it's very correct. Yeah. And the muscles, as you just mentioned, is of course also helping, because when you go into cold water and you do a dip or you swim or whatever, when I say winter swimming, I of course also just mean cold plunging. It's just different words for the same thing. But you also activate your muscles because they start shivering at some point. So by doing so, you also increase the mitochondria in the muscle cells, which will then also increase your metabolism. So it all works together to increase your insulin sensitivity, which we just touched upon. So
where is brown fat typically located in the body? Where do you see it? And by the way, I believe the way that you were studying these participants was it a PET scan?
A PET-CT scanning,
yes.
A PET MRI actually. So we did the PET and the MRI scanning to see, because we can then see with 3D, we could see the tissue also in the body. So the MRI scans were really good to locate also where is the brown fat. And we measured the supraclavicular brown fat depot. We also measured the depot around the kidneys. But in my research study, we focused mostly on the biggest depot, which is under the supraclavicular bones. But
so for those that are listening, you're pointing kind of like right around your collarbone.
Yes.
So you're saying that that's the largest concentration
Yes.
deposit or depot, as you're saying,
Yeah.
of brown fat.
Yes. So you have 6 deposits in your body, which is shown by a really nice study from Leitner et al. From 2017. They show that by these PET-CT overlays, how, they could see from different participants in this study, from these overlays, they could pick out, or they can show where in the body is brown fat located. So it's not just one picture of one subject showing where is the brown fat in the body, but with these overlays, it also shows the potential of growing your brown fat. Where can we grow more brown fat in our body? So it really shows that there's this 6 depots. So it's a lot of depots actually in our bodies. And it's called an organ because it's so different from any other tissue or cells we have in our body. So it's actually an organ also. But all the depots are located around our central nervous system, which is very interesting, I think. But the largest depot is under our supraclavicular bones, and we have it down our spine, and a little bit around the kidneys and around the heart, and we also have it up on the neck, and also in our what is that called?
Armpit?
Armpit, exactly.
Yeah. Okay.
I lost the word. Yeah.
And why do you think there's so much? I mean, you mentioned that a lot of the brown fat depositories, which are located around these 6 different sites, but the biggest one being around the collarbone area. You're mentioning that they're around our nervous system, the centralizing of our nervous system. Why is that? Is that a protection mechanism that the brown fat would be located around those areas?
Yeah, I think that's one of the things that, of course, we can debate that. There's not going to be a clear answer to this, but I think I started to think a lot about this while I was doing my research, because I was thinking, well, why don't we just, because people are asking me, can I activate my brown fat in my arm if I put my hand into cold water? I'm like, but you don't have it in your arm. And then I was thinking, why don't we actually have it in our arms and legs? But it's located around the central nervous system. And I think this is pretty much explained by the way it's activated. So the brown fat is activated from different pathways, shown by research that is a little bit older, but also some new studies showing that it's primarily activated from your brain. So we have our temperature regulating center up in our hypothalamus. So temperature sensitive receptors in our skin would send a signal to this center in our brain, and that's going to increase norepinephrine and activate on the surface of the brown fat cells. And it's going so fast because it's so closely located around our central nervous system. So it's really a survival organ that we have. It needs to be in front of our, you can say, it needs to have the message right away. And that is probably why it's located so close to the central nervous system and around our central nervous system down our spine as well. There's also another pathway, and that's going directly from our temperature receptors in our skin, directly a message to the brown fat. And also there is also a pathway from the muscles directly to the brown fat. So it seems that our brown fat is a survival organ that we have that is going to be the first responder to our environment. So if you think back when we didn't live in these perfectly isolated houses and we were living out in nature, you can really think about the brown fat as super important for our survival. And that is probably why we are here today. We are the surviving species, you can say. And I just wonder, the other human kinds that were before us, or we were the last one standing as we are, didn't they have as much brown fat? Didn't they really have this kind of mechanism? What is actually going on? Because we kept this and we still have it today. Or actually, are we losing it a bit? That is maybe the question that I cannot answer right now.
Yeah, but it's a fascinating question to think, how did we get here? Why do we have this ability? But also, what's going to happen to us if we start losing this?
Yeah, I think that is really interesting that by 1980s, we can really see this growing pandemic of obesity, right? But we could also see a growing tendency to stay more in a thermoneutral state. And I think that there is a relationship between this. So as much as we get more sedentary, we also decrease our activation of our brown fat, of course, because we are not exposed to temperature changes. And that is what is keeping your metabolism up. So if you don't do that, then your body, your cells are getting lazy, and you're not using for anything, and then you have this imbalance in your body, in your metabolism, in your cells. And I'm not questioning whether this is actually has something to do with increase in obesity and an increase in also anxiety and depression, as we see World Health Organization is putting these statistics out. So we kind of know that this is a growing problem. And I think that the brown fat is one of the things that we can target to help this crisis.
Absolutely true. And, in America especially, and around the world now, the world becoming so westernized, there's been so much emphasis placed on exercise, right? Like traditional exercise, movement, strength training, going to the gym. And obviously there's a whole list of benefits that are there. But in many ways, the gym isn't always the thing that everybody wants to go to. And the reason that I found the work that you were doing in cold exposure, and also you summarizing a lot of the literature on hot exposure, which we'll get to in a little bit, is that you look at these things and in the body, you see a lot of similarities. Many of the benefits that people get and many of the pathways that are activated in exercise are also activated in cold and hot exposure. In fact, as someone who is really close to his parents, my parents, they live in San Diego, and I'm always thinking about how to get movement into their lives on a regular basis, especially because we come from a South Asian background. We're Indian, and that's typically a society here in America that you're, a working professional and you're more sedentary and you're more insulin prone, right? You're more insulin resistant prone as a population. And you just typically don't have a culture that works out as much in that group, right? And so walking is one of the things. So, my dad gets in 10 to 18,000 steps. My mom is now around 10,000 steps. But also when I was looking at the literature, myself and my brother-in-law, who's a cardiologist down in San Diego, it's like, if we can get our parents to do sauna and also some little bit of cold exposure to the degree that they can tolerate, it's as close to exercise as kind of what we know is available to us right now. Do you think that's a fair statement?
Yeah, I think we can absolutely use it as an add-on. I would always advocate also for exercise, of course, but as you said, there's also a minimum dose that you can do. So any movement you can get into your life is going to help you. Even going for a walk is something that is proven with science has a beneficial effect on your metabolism, on your insulin resistance. So I think that anything you can get into your life, what is feasible for you, also regarding the cold and the heat. So if you don't have a cold plunge or you don't have open sea nearby, you can also go and take a cold shower. 30 seconds is actually enough also to get that metabolism going, increase your happiness hormones and neurotransmitters in your brain. But also washing your hands and your face in cold water is going to activate the brown fat. And I tested this, and other studies have also tested this. And you can activate your brown fat by exposing just parts of your body to cold. So you can start off with hands, face, or cold showers. And then when you get a little bit more adapted to that and the idea of actually using the cold for anything, then you can maybe expand by going into the sea or maybe buy a tub or something to go into.
Yeah, I want to break those down because we have a whole list of sort of the recommendations that are there and how people can integrate them into their life. You mentioned cold shower, cold bathing. There's, of course, winter swimming. We'll talk about cryotherapy, splashing the face with cold water, which is really fascinating and I think going to be an interesting way for some of our audience to get started. Before we do that, just set up your study for a second. How many people was it? And what was the protocol that they were on in the study that led to all these benefits that you described previously? How frequently were they going during the research to have this cold immersion?
Yeah, it's a really good question. And that was also one of the things that I struggled with a bit in the beginning and that's why I did all this research on just watching winter swimmers in Denmark. And as I told you, I wasn't really a fan of the cold myself. I was just scientifically curious, I think, about the whole thing. So I wanted to find out what is the minimum dose. With how little could I get away with this? So if I was supposed to use this protocol myself, I had to go with as little as possible. So I found some winter swimmers, or I found out that mostly winter swimmers in Denmark who don't do this in an extreme way, they go a couple of times a week and they only do short dips, which is like 1-2 minutes, and then they go up and they go into the sauna and stay there for not that long either, 10-15 minutes, and then they go out again. And then it take another dip, and I was like, okay, that seems. And then I asked them, why do you do it this way?
Right. So first they're doing cold, right?
Cold.
So typically, and you have some beautiful images inside of the book. There's these lakes that are there.
Yeah.
Right. Or it could be the ocean.
Could
right.
be.
And people are dipping in. There's these little carve outs. They've like carved out a bunch of ice for them to go in. Then they're going to hot, but then interestingly, and you'll explain more about this, they're going back to cold.
Yeah, so they alternate between the cold and the heat, as you just explained. They start in the cold, go into the heat, and some others do it differently. But I kind of put that protocol up because I wanted the outcome of increasing metabolism, right? So I wanted them to start off with the cold, go into the heat, the cold, the heat, and then end on the cold. Because if my hypothesis was right, then they should end on the cold to increase their metabolism by forcing the body to heat itself up. And that is by activating the brown fat and forcing the brown fat to increase your heat from the inside. And that was really important for me because that is going to increase the sensitivity of the efficiency of the brown fat cells if you just heat up by yourself. And
versus heating up in the sauna.
Versus heating up in the sauna or going directly home to take a warm shower. And so I wanted to recruit subjects who didn't do it in an extreme way and only did this a couple of times a week. And a lot of people did that. So I had a lot of people signing up for my study. So I could easily match this to a control group, which is they were matched on age and BMI, fitness level, diet actually also, and on age and gender. So we did the studies on men who were on average 24 years old. So I wanted to study a younger group because then the success rate of them having brown fat was higher.
Versus an older population who doesn't already have that much brown fat to begin with.
Exactly.
And they might need a longer protocol to get that brown fat up before you could study them.
Maybe. And I was doing a concept study, so a proof of concept. And because there was nothing out there and to get the funding also, I needed to do like a proof of concept. So I needed to study some who were already doing winter swimming and match them with a control group to see if there were any difference between them. So to make the difference between the groups bigger, I needed a group who were already adapted to the cold. I figured. So that is how it started. So the control group is very matched to the winter swimming group. They were also the same fitness level. So they started out doing this protocol, just telling them how to do it, but I didn't tell them how long. That I was just observing and monitoring that, and it ended up being 11 minutes per week in the cold water and divided on 2 to 3 days. And with each day, they did 3 dips and ended on the cold. And they also went into the sauna, which was 57 minutes of sauna per week, divided on 2 to 3 days, so on the same day as the cold, but only with 2 visits. So if you divide that up and you do this a couple of times a week, that means you can do your cold dips for 1 to 2 minutes is enough per dip. And also going into the sauna would be 10 to 15 minutes is also enough.
Very feasible, very manageable.
I think so. Even for an elderly population, this would be feasible because it's not too much. And if you don't suffer from heart diseases or unregulated high blood pressure, then this should be safe for you.
And just to add in, you were studying younger men, but very regularly in these winter swimmer groups, which you were saying, interestingly enough, that people often refer to them as the happy winter swimmers because they just have a general sense of happiness and
Yes.
playfulness. There's a few photos inside of your book of them being very jovial and kind of wearing, eccentric bathing suits. Like it's a whole lifestyle, right? It's a whole like fun thing. But what I was mentioning is that even though you studied a younger population and mostly men, when you observe these winter swimmers, and in Denmark and around the world, there's a lot of older people that are doing it too. So this is really for anybody at really any age.
Yes, it is. And I think it's just important just to mention that if in science we sometimes have to do like a very rigid protocol studying a certain group, which sometimes can look like you have excluded some others.
Right.
But that is just how science sometimes have to be done to be able to prove something, then we can move on to the next question. Right. And I think that it's very fair to ask, why didn't I include women, for example, in the study? And I really wanted to, but at this time we knew that women have generally more brown fat than men. And they also have, because of the cyclus, they have the hormones going up, and it's really, really difficult at this time to compare men and women on this, because we didn't really know whether this is going to make the difference between the groups. And if you want to do a proof of concept study, you need to go small, because we wanted to. You could go you can make a really big study, right, with a lot of people, thousands or hundreds of people, but then you don't measure as many things as we did.
Sure.
So we could do a large study, measure maybe one or two things, or we could do a smaller study, but you can say explore more things, and that is what we did actually. So
yeah, you did. And again, with this proof of concept study, the goal would be to hopefully inspire more people to be doing, larger studies, or maybe somebody might look at women, or somebody might look at, an older population. But you really did find a lot of specifics that were there. Like one of the things that came out of it, we talked about insulin sensitivity. You used a glucose. In addition to that, you looked at better glucose response through a glucose tolerance test.
Yes.
Right?
Yeah.
And you also found that there was higher energy expenditure, just in general, like during the cold that they had. So they're outputting more energy, which means that they're probably also burning a little bit more calories. Is that fair to say?
Yeah, that's fair to say. And it's not only when they're in the water.
It's even when they're out.
It's also when they're out, because they are increasing their metabolism by heating themselves up naturally, which is, I also have to mention that it's called the Søberg principle. And it's named by Professor Andrew Huberman, who is also the host of the Huberman Lab podcast. Fantastic podcast.
Yeah, he's been on here a couple times.
Oh, he has? Yes. Oh, fantastic. Yeah. He's great. Yeah, exactly. And he named this the Søberg principle. It's so nice of him. But this ending on the cold is actually forcing your body to increase your metabolism hours after you go up. So this is not just a training by going into the cold for 1 or 2 minutes. Then people ask me, oh, is that enough? But it depends on how you do it, of course. So if you keep yourself cold or just keep moving afterwards, that's also increasing your insulin sensitivity by moving your muscles, and just accept the little bit of shivering that you will have afterwards, because that is really good for you. That is also increasing your exercise and exercising your muscles.
Yeah, and to connect this together, just because I think that's really the magic of what you found, is that in this 11 minutes of total exposure in a week, right, that you found from the study, and like the minimum viable dose to get these benefits that are there, broken up over 2 to 3 days, right? And then, in your study, people were doing kind of multiple dips, kind of getting in, getting out, going to heat. But most importantly, when you're ending on cold, and again, the Søberg principle that you mentioned is letting your body naturally heat itself up. Don't try to force heating. Don't run to the heater. Don't jump in the sauna at the last stage. Let your body naturally heat up. That's where the magic is going to come from.
Yes, exactly. And
fascinating.
It's gonna be hard in the beginning, and there are some people asking me, well, isn't that a little bit extreme? I never thought about it that way. I just didn't have a sauna myself in the beginning, first couple of years actually, being a winter swimmer. So I have done this myself heating up naturally. And it's a little bit painful in the beginning, just like starting out running, for example. You don't start with a marathon, but when you start with 2 kilometers, 5 kilometers, it's going to hurt a little bit. That hormetic stress is painful a little bit. It's natural. So when you feel that, shivering, it's cold, and you really want to jump into the hot shower, just try and not to do that. Just tell yourself, this is exercise. This is really good for me. Just keep moving. You can clean your home, or you can go in the garden, or just don't sit on the couch, because that's when the shivering will start then. Then you'll be colder.
And it's all about a mindset, as you shared previously, because if you think, I've had friends who I've taken them to just down the street. There's a place over here that I go to that has cryotherapy because my cold plunge in my house is not available right now. I have to clean it and do some other things and whatnot, but I'll take them to cryotherapy. And they'll say, I don't like to do it because I'm cold for a really long time afterwards. And they think of that as a bad thing. But imagine if we said, I don't want to go to the gym because I'm sore afterwards. Yeah. But everybody understands that being a little bit sore is part of the gains that are there. That's where some of that beneficial stress comes from on the body. Yes. Another thing that you noticed is that, if I'm getting this right, noradrenaline was sustained for hours for the people so tell us why that's important and what you noticed from that.
Yeah, so noradrenaline is the activator of your brown fat, so your metabolism. So noradrenaline increases by 2.5-fold at least when you're going to submerge yourself up to the neck in cold water. And that's going to last for hours after you also go up, especially if you end on the cold, because the body is going to keep the body in that a little bit of a fight and flight mode afterwards, because you need it to increase or activate your brown fat. And you can benefit from this because it gives you a focus, it gives you drive, and it gives you that energy to do whatever you want to do in your life. So you don't have to fight for getting, for example, energy to do something, because it's already just physically there in your body. So if you lack energy and you lack, you can say drive, you can use this as a way to kickstart yourself or kickstart your brain and your body. Just do it. All you have to do is decide to do it. And then when you do that, you have everything going in your body. It's going to help you in that way.
We mentioned this in the beginning too, the dopamine. You noticed that they didn't have a crash of that dopamine, and it was sustained for a long time. I know I mentioned in the beginning, but that's such an important thing in this world of short-term pleasure seeking, and so many things fighting for our attention during the day that give us that little pleasure hit, like on social media, people feeling, addicted to shopping online, or, even sweet things. Sweet things give us this little hit of dopamine. But you noticed that there was this dopamine increase that was there, and it lasted. It was a slow sort of release over a while. Was that in your study, or was that with other studies?
This is with other studies.
Okay, got it. So we didn't, my apologies for that.
No, it's fine. It's fine. It's not measured in my studies, the dopamine, but we can see from other studies that dopamine increases, and it also lasts for hours afterwards. So we can definitely look into what does dopamine do for the body and for our mental health. And as you just mentioned, the fast dopamine kicks that we get from being on social media and for eating sweets, for example, snacking and other reward-seeking behaviors is what's dominating in our modern society today. So whenever we seek this kind of rewarding things that we do, behaviors, that is going to give us more crashes during our day. So every time we seek this, we should think about that we will have a downfall, we will have a down period at some times. And it's pretty much right after. As soon as we shut down the social media, we can definitely see this in kids as well. They crash afterwards. But when we do cold immersion and also actually going into the heat, we could see that this increase in dopamine and noradrenaline and also endorphins, it's gonna last for hours afterwards. So you don't have that crash, but you just have that benefit to go out through the day, and it fits the circadian rhythm of these neurotransmitters as well. So nature is really clever in this way. It has really thought about, or it just happened actually, that that we benefit from being out in nature, and we were born into this. So it makes sense that nature and cold and heat is what we grew up in. We were made in this, so it's in our DNA, and it kind of resets our cells in every way, both mentally and physically.
I even know there's days where I just feel like a little sluggish. Maybe it was a stressful week, and it's like I don't feel that great. Maybe I didn't sleep as good, and I go do cold immersion, and it just feels like it's like I'm sure there's probably some pharmaceutical companies out there trying to figure out how they can recreate this. But again, we have it inside of us, right? We don't need that drug. Maybe one day we'll have it without side effects. I don't think so, because nothing in life, is obtained for free without some sort of benefit that's there or some sort of challenge. So, that's how I've used it, is that I go and do it, even though I'm like, I don't want to get cold today. I don't feel like it, but I'm like, all right, I have a buddy. I do it with a friend of mine. His name is Mark. You're actually going to meet him tonight at dinner.
Okay,
He's a sweet guy. So we do it together and we encourage each other. It's like, hey man, how are you? Yeah, it's cold outside. It's raining. It's, we don't feel like doing it. And then we do it. We're like, let's go. And in fact, you notice that a lot of the swimmers were sort of making these like sort of Tarzan type voices after they go and do this cold plunge, because they feel so activated and ready to take on the day and to take on life. Yes. I think that's really great. And that's what I feel sometimes too.
I think it's brilliant. I think, and this is universal. When I did my studies, I thought of this as very much a Nordic thing, very much only Scandinavia. And I know it's very predominantly there, but I found out later that this isn't the whole world. And everybody feels kind of like the same way about it. They feel this confidence afterwards. They get this energy, and they get this feeling of they can conquer the world, almost like Tarzan. And especially men are like, yeah, I can do this. And I find that's very interesting, what is actually happening there. And I just want to mention a really interesting study that was published here in January 2023. It's from a research group in the UK, where they have looked into the psychological traits in the brain, what happens, what kind of centers are activated when you submerge it into cold water. And they found that after exposing people to cold water, they change in the positive mood they have, so in the traits. So they felt after a month, they felt more confident. They felt this energy, and also they felt less anxious afterwards. So they have this mood pattern that they explored in this study, so psychological traits. So I think it's very interesting that this is also what we see. So very universal, not only for Denmark or Scandinavia or only for men, it's also for women. So this confidence that people feel afterwards, and that increases, people can use this. It's a force. It's like magic. You can use this in your everyday life. You can go out and you can have more confidence when you go into an interview or an exam or whatever you find could be a little bit stressful for you. With that confidence, and you would lower your stress for doing everything that you might find stressful before that. So with more confidence, we can do more, I think. So it's very important, I think.
Yeah, I've heard this, I would share this quote with my men's group who's also into, cold therapy. And I would say either you kick your butt, right? Either you kick your butt or life will kick your butt. And life is going to kick your butt anyway. Yeah. But if you do it first, you just have a little bit more resilience in it.
Yes.
And it's the reason we have to do tough things. We have to
yes.
lift heavy things. We have to put these positive stressors on our body. It makes us more resilient. And also I think our nervous system is these things that are in my head that I'm just worried about, this email from my boss or this stressful situation that's there. It's not that they're not there. It's just they don't feel as big of a threat when we go through things like cold therapy and hot therapy. Our body just feels, and our nervous system feels more ready to take those things on. Exactly.
And I think you said it very right there. So mental stress is what we have today, not any physical stress. It's too little physical stress. And I think that the reason why people are not really keen to go into the cold is also it's very present when you're there, right? You feel the pain right away, and you don't feel the stress dripping during the day like you do this kind of modern lifestyle stress that we have. But this kind of stress, submerging yourself into the cold, is present right away. So you feel the pain right away, but it's very short. But when you do that and you go up afterwards, you will have a pain relief almost, and especially mentally, I think. So that's going to wipe out anything you are worried about, all the stressful emails, your boss being after you or whatever. All the worries would be gone when you submerge yourself into the cold. And then when you go up afterwards, and I think this is the reason why people get so happy afterwards, because you have all these neurotransmitters going in your brain after your dip, and you then will return, of course, to your worries, but then you will see it in another perspective because you have a more positive mindset.
You wrote it so beautifully in the beginning of the book. This is page 26 in the introductory section about, why should we swim in the winter? You wrote, the shock of the cold water demands full attention from our body and mind to survive, because the mind interprets the cold water swimming as a life-threatening situation. And even again, I just want to say it again, because there's a lot of, propaganda that's out there. It's fading away, where people will make you be more worried about cold water exposure. In fact, Tessa, there was an article that I asked you to just bring up as an example. I'm not trying to throw the American Heart Association under the bus, but this is an example of some of the propaganda that's out there. The title is, "You're Not a Polar Bear. The plunge into cold water comes with health risks." And if you scroll down, there's this quote that's there from this doctor, who I'm sure is well-meaning, and like a lot of things that are out there, things get blown out of proportion. People don't know the research. They also see maybe or read about one or two cases or instances that things don't go well. So yeah, it says, the doctor over here says that cold water shock can be dangerous. He's a director of preventive cardiology at Brigham and Women's Hospital in Boston. Whether there are health benefits or not is not clear. It has not been established. And I think that a lot of things that are out there, because people will talk about doing cold water immersion with your friends, and sometimes the immediate reaction from people is that, I don't know, that sounds dangerous, or I read this title of some article, didn't go into it. A lot of people are just not aware of the research that's out there. And again, like anything, you can drown in a bath at normal temperature water. You have to have some of the basic common sense precautions. But this fear that we have, I really hope that we kind of set that to a side a little bit. And otherwise, we'd be missing out on so many of the benefits that people could experience. But one of those benefits being, it's such a shock to your body. And even though your body feels like it's dying, which is kind of an extreme thing, but internally there's this feel of like, whoa, what's going on? It forces you into the present moment.
Exactly.
And that's exactly what you were talking about.
Yes. Exactly.
So I know that was a little bit of a rant, but I feel like it's important to address.
Yeah, I think also, fear has a strong voice, right, in your mind. So, and there's also, and it comes from that as well, when people write about this. Also, just the knowledge has to get out. And it takes a while. It takes a while for people to get notice this and notice the science. Of course, you can't expect all cardiologists to be completely aware of the new science and also connecting the dots with the older science, because it takes a while to get through all that literature and understanding it.
And there's no drug company that's there trying to educate
promote
them.
It. Exactly, yeah.
So unless if they have a genuine research, or unless if they're fans of Dr. Andrew Huberman or Dr. Rangan Chatterjee and listening to their podcast, which I'm seeing a lot with the younger generation. I mentioned to you, my brother-in-law is a cardiologist. He loves to just stay on the latest. And there's this whole new group of people. And I say young, but there people of all age that are youthful-minded. Yeah. They're open-minded researchers, practitioners, physicians who are like, okay, much like you in the beginning of your career, you were saying that you were working in the hospital, was it? And you were feeling like by the time that we're helping them, it's too late. Yeah. There's a crisis. Yeah. What can we do to have people in a way? Yes, you need a doctor, and everybody should have access to a doctor, but in a way you become a little bit of your own doctor by doing the things that are safe at home preventatively that anybody can do and anybody can access.
Exactly. And I think it's also, of course, it's very important also to talk about the cold water as something that you should be mindful around how you do it. And that is also why we are debating also how much and how long and what is healthy and what is healthy stress. That is why I'm micro-stressing, as I call it. Micro-stressing is stressing the body in a healthy way and not overdoing this. Right. And that is possible, definitely. I'm sure this is possible because there's this scientist, very famous scientist, Hans Selye, who discovered the stress syndrome back in 1936. He published this in Nature magazine. And So one of the best peer-reviewed magazines in science. So he published this because he discovered that if you expose your body or cells to a stressor, then you will have an acute response. But in the next phase, if the stressor is still there, it will create a resilience in the cells and it will build itself stronger. So, but if you keep exposing your body or your cells to that stressor, it will go into phase 3, which will then, it will exhaust the cell, and then it will age faster, and then it will, age faster. But if you stay in phase 2, which is the healthy stress, the eustress, which is also called, then it will... Eustress.
Okay.
Yeah.
Yep.
So that is the healthy stress. So microstressing, or homeostasis is the process in the cells. So that's going to create resilience in the cells, and it will repair the cells, and it will prolong the life of the cell. So it will actually make the cells younger in that way. You will keep your cells healthier. So that is because of the heat shock proteins building up inside of the cells, and repairing the proteins in the cells so they will live longer. But if you then overdo it, and that's just back to what you just said with this article you found online, is that if you overdo it, you can definitely harm the body also. So it's also a question about finding that balance that will keep your body in homeostasis, so the healthy kind of stress. So that is what we are looking into. But I think that 11 minutes per week, and if you can stay there or around that number, then you are on the sweet spot, on the sweet side of it.
Yeah, absolutely. So let's dig into that a little bit. You know, we've talked about these different ways that people can begin, right? So in a world of working yourself up to, right, we're really talking about cold submersion, which again, in the book, it's called like winter swimming because that's what the folks were doing. But what you found and extrapolated in is that being submerged in water, which means your neck down, right? You don't have to put your head under the water. No. You keep your head above the water. And we referred to it multiple times, but this 11 minutes total exposure in a week that could be broken up into, 2 or 3 different days. You also, I heard you mention that everybody's asking how long. So that kind of addresses the minimum dose. And then people are asking how cold, which is a spectrum. But generally you've said, extrapolated to Fahrenheit, it's about 59 degrees, right? Mm-hmm. Starting at 59 degrees and lower is where those benefits come from. Is that correct?
Yeah.
Okay, great. So now we know how long, which is the 11 minutes broken up into, 2 to 3 days in a week, and how cold is we're looking at that 59 degrees and lower. Now, here in the US, if people are landlocked or they're living in the, middle of the country, they may not have access to colder temperature waters, but even then, sometimes people have lakes or other things like that. There's a big movement of these ice baths that people do. But even if you have a normal bath in your house, you're saying that you can take a cold bath.
Yeah.
That the faucet, the water from the faucet, even if it doesn't hit that 59 degrees yet, it could be a good starting place because at least it's getting your body more ready for colder temperatures, right? And I think part of why I'm bringing that up is that we're not asking people to be in, 30 degrees freezing water, right? Even 59 degrees is enough to get started, right? So let's talk about some of those. So the first one that people can do is if they have a bath at home, they can get that temperature, starting at whatever is the coldest it can do. And then if you want to add a little bit of ice to it, you can kind of chill it down to that 59 degrees. There's also people having the ability to do a cold shower. And a lot of times people ask you, is there still benefits with the cold shower? So talk about cold shower and how that fits into this if people don't have access to a bath, and how much that's studied in the literature or not studied in the literature.
Yeah, so very good question. And I think it's really important to also bring up some protocols or methods for this that's going to be feasible for all, because I think that all people should eventually try out cold exposure and also heat exposure for their health. So cold showers is definitely a feasible way for most people because everyone has a shower, right? So everybody can turn the handle to the cold side and have it as cold as they can, and I'm pretty sure it's going to be enough because most water can go down to a cold degree, which is going to activate your sympathetic nervous system. So and with that said, there is a study from Holland, a randomized controlled trial, where they have studied ending on cold showers. So a hot shower and then ending 30 seconds up to 90 seconds on a cold shower. So they built this up. They showed that if you cold shower for 30 seconds and up to 90 seconds, you will have a decrease in sick days from work. And you can ask, why is that? Well, and it's probably because of the activation of your immune system, but it's also your metabolism, but also the neurotransmitters will also increase in your brain. So you have the dopamine, noradrenaline going, which is giving you energy and you give you drive, and also endorphins and serotonin is also going to be activated probably. And also oxytocin. So oxytocin is our love drug, you can say, in our body, which is also a stress hormone. So it will be activated to survive also. So with all that going in your body, you can maybe ask whether people have less sick days from work because they were had a more positive mindset, which made them go up in the morning and went to work, even though maybe feeling a little bit like not really that well. Or it was actually both also activation of the immune system, which then will defeat these viruses or what they had. So it could be both. I think maybe could be a reason at least. But cold showers is definitely a way to go. There is not much literature out there, but this study I think is very powerful. It's a randomized controlled trial.
Still could be some benefits,
yeah.
But just to be clear for people, it was not the plethora of benefits that you saw in your study is really through cold immersion and winter swimming.
Yes.
Right.
Yeah.
And also too, I don't know if you've ever tried cold showers yourself, but I find them actually more difficult than winter swimming and cold plunges.
Yeah.
Because, typically like, if people don't have like an overhead shower, head.
Yeah.
You are getting cold on like one side of your body and then the other side of your body is warm and it feels like this is really tough to do.
Yeah.
Versus when you submerge yourself in cold water through a plunge or an ice bath or something like that, your entire body is cold at the same time. And it's more of a shock to the system, but in a way you don't overthink it. When I'm in a cold shower, I feel like I don't want to do this anymore because my back, if the shower's on my back is cold and my front is warm. So I'm like thinking about the contrast in the temperature. Have you noticed that at all?
Yes, definitely. And that is, I have the same reason for not doing the cold showers. I don't do that very often because it's more uncomfortable for me to do than going in than cold immersion. And it's not like we shouldn't seek the uncomfortable. We should. But as you just said, it's also about how does the cold water hit your body. And of course, you can do like a movement where you have the drops or the water hit your chest and then your back, and you can also bend a little bit to like even it a bit out. But it's like you will activate your sympathetic nervous system because you don't submerge into cold water when you do the cold showers. You won't have the same degree of activation of your parasympathetic nervous system. So you don't get the activation of the resting part of your nervous system, which I think is very important also to get that mental balance and increase in serotonin, which you do when you do the cold water immersion. So I will always say that cold showers are really good, and it's also good for giving you drive and energy because that's going to increase when you do that. But if you want to also create more resilience, so stress resilience, mental resilience, and also get the adaptation to cold water, you need to submerge into cold water. And there are studies actually, you can say, comparing two groups. When one group did cold showers at 10 degrees Celsius, trying to convert that to Fahrenheit.
50 degrees.
50 degrees Fahrenheit. So, okay. And they saw that if they practice cold showers at 10 degrees, 15 degrees Celsius. And they then, some weeks later, after they have exposed themselves to this, and they submerge into a tub with cold water at the same degree as the cold showers, they were adapted. But if you just turn the temperature down a bit, so maybe at 8 degrees or at 10 degrees Celsius, then they will start to hyperventilate again. So they measured this on on hyperventilation. So breaths per minute, what it was. Yeah.
Got
So
it.
you don't get cold adapted. That was the message. So you don't get cold adapted from using cold showers to other temperatures than your cold shower.
Right.
So, but you do that when you go into a cold tub, then you will be resilient on different temperatures, of course.
Another thing that I found very interesting about your work and research is that you also found that, it's not about continuously necessarily going colder, especially if people are doing winter swimming or, I live in Los Angeles and a lot of people go to the Pacific Ocean, which is pretty much, cold year round and definitely a lot colder in the wintertime. Even going at varying degrees of cold can still be beneficial to people, right? Is that accurate?
I think it's accurate. It's something that I
feel.
use.
It's an observation.
Yeah, it's kind of one of my philosophies around the cold water and temperature and what temperature is healthy for us. I think that if you change the temperature just on a theoretical level, so you would then increase, you would challenge your cells in hormetic stress, so you don't get too adapted to one temperature. It's just like the weight on your weight belts when you go training in your training center for your muscles. You would change both the repetition, but you also change the weight on your weights to create this hormetic stress and to grow your muscle cells. And the same way, when you go into cold water, you should change the temperature just to keep your cells always working and increasing hormetic stress in the cells. So this is the healthy stress. So by changing the temperature, you will keep your metabolism on its toes, and you will also because you cannot, at some level, you can't go lower in temperature, right? Then it's actually beneficial for you, I think, that going a little bit up and then go a little bit down again in temperature.
Is there the safest degree cold that people can go if they find it that they're tolerating it? Like how cold? You're pretty much staying at freeze. Like you can't go and the water's going to freeze. So the water that people are going into in winter swimming is what is that temperature when in Denmark, like at its coldest?
Yeah, I think it's beautiful because in nature, you don't have to think too much about this, right? If you have seasons, the nature is going to do all this for you.
It's going to have the natural fluctuation.
Natural variation in temperature. And the temperature in Denmark is actually not that cold. We don't think so.
The air temperature, you mean?
The air temperature, but also the water. So it rarely goes below 0 degrees Celsius, so freezing point. So if we look at October, where our winter swimming season starts, we have like 9 degrees Celsius. That is pretty much that is a really cold month then for the water, but it doesn't go below 1 to 2 degrees Celsius in January, and then it goes up again actually. So not that cold.
Not that cold. Not that cold.
Around.
And again, we're talking about 59 degrees and lower is when you start to see a lot of these benefits. You mentioned something previously, which I think could be an interesting way for people who are, really skittish about starting off, even splashing your face with cold water and maybe getting some water activation on your neck as well too, which is probably close to some of that brown fat, that could be beneficial. So how could somebody start off with that? Is it just starting your faucet on a cold setting, putting your hands underneath and washing your face for a little while?
Yeah, it could be. I mean, we all have people have to get used to this thought of like going into the cold in some degree, right? And in the beginning, when people hear this, there will be friction in the brain. It'll be like, no way, I'm going to do this. And all cold plungers have this thought at the beginning, but it takes a while to get adapted to the thought of going into something that is really cold because we naturally are trying to avoid it, right? So it's going to take a while for people to get used to it. But if people just want to like have a really easy way of starting out, it is beneficial for you to dip your hands in cold water. It could be a bucket of ice and water, and you can put your hands in there and see how does that feel. For me, it's not very nice. I feel it's painful for my fingers. So it definitely for women, I would not recommend that one. But splashing your face with cold water will activate also your vagus nerve. So that's going to give you this relaxing feeling afterwards. You're feeling fresh and have this energy because you also activate the sympathetic nervous system, have noradrenaline going. But it's a way of starting. I think there's these interesting studies in fishermen. who put their hands, they work with their hands in cold water all the time. And there's this research group, they studied them to see if they were cold adapted from just having their hands in cold water all the time and working. And they showed that they were cold adapted when they submerged them into cold water. So I think that it really shows that exposing your body parts, just body parts, to cold will give a systemic effect in the body. And I think it makes sense because, I mean, we are one organ, right? It's just one thing that is, we are connected, right? Body and mind. So when you put your hands into cold water, that is going to affect your whole body. So it's not only just the hands that are getting adapted to cold and your face. It's going to have like a systemic effect. Of course, not as effective as submerging your full body up to the neck, but it could be a good start.
Could be a good start.
Yeah.
Yeah, it could be a good start for people. So a couple sort of questions that I know that you get a lot from individuals. One is that people ask, can kids practice this? Can you take your kids along with you? You have kids.
Yes.
Right? And I've read in the book that they've come with you a couple times. Yes. Right?
Yeah.
So is it generally considered safe as long as there's an adult that's there with them for kids who, as you told us and reminding the audience, have more brown fat? Is cold exposure, winter swimming generally considered safe for kids?
Yes, I think that if we are wise about it, because I of course looked into the literature around this and how does a body, a smaller body that is exposed to cold water immersion, how does that react compared to an adult body? Is there any difference? And I found these interesting studies, there was a few, where they measured the core temperature of children compared to adults, and with like same body composition and fat percentage in both the adult group and the young children. So these boys were around 12 years old compared to an older group, and they found that if they were exposed to cold water immersion for about a minute, the children could defend their body core temperature in the same degree as the adult group could, but they did it in another way. So meaning that because they have a larger surface ratio to their mass compared to the adult, they would activate the muscles before the adult would, because they get easily cold. They have less mass, right? So just to get to the conclusion of that is just to say that there is some research about this, but also to back up my point, which is that if you take your children along with you, think about them as it would be healthy for them to go into the cold water, but very briefly, and they should be able to get into some warm sauna and also very briefly there, it's the same thing, or be able to drink something hot and also take their clothes on again, so they will decrease their temperature faster than an adult. So it should be very brief.
And so in that sense, for a lot of people listening who have kids, can that same protocol that the winter swimmers do, obviously at shorter times, are kids still ending on cold and letting their body naturally warm up? Or do you think that kids should kind of be warmed up by something warm, like a sauna, or kind of heat up? Like, how do you, I'm sure there's probably not literature on it, but if you would say, advise to people, or it just depends? Well,
I let my kids heat up by themselves.
Yeah,
because they just run. I mean, they are not sitting still on the couch. I mean, as long as they're running and they're having fun and they're still smiling, I mean, they can heat up by themselves. This is like not something that is like has side effects in that way. It's just cold.
And kids, any parent knows this. Yeah. I'm not a parent yet, but I've just seen it with my nephew and niece, and just even as I was a child, I used to love to just go outside in the cold with my bare feet. I wouldn't even have a jacket on. And everybody would tell me, adults would say, put your jacket on, you're going to get sick, you're going to do that. I didn't get sick, and I also, it felt good to be outside. I'd be outside and just have a t-shirt on, it's snowing in the middle of winter, and I just felt like, oh, this is cool, this is good, this is fun,
Yeah.
So kids are just generally more well tolerated.
Much more, and they have more brown fat. So, and that's going to help them heat up again. So, and they move more. So it's just, I think it's fine as long as they feel fine. they can talk. So if you can ask them, how do you feel? And, so I think as long as they move, I think everything is fine.
What about pregnant women? What have you seen and observed? Do you ever see pregnant women doing this in Denmark or exposure?
No, I don't. And I would just say that I would not recommend pregnant women to do this, just also because we don't have enough research around this. How does it affect the fetus? Or it's really important that we don't give advice to a group who is understudied in this. So I would just say, hey, take a break for 9 months. Think about this as a nice break because you are doing something else in your life, and there's a time for everything. Sure. So, and after the 9 months, you can rely on that your body will remember your cold tolerance. There are studies showing that if you have a break for a year, your hyperventilation will still be less a year later than when you started the year before. So it really means that your cold tolerance will be remembered in your body a whole year later. So it's not going to be from scratch when you start again. Yeah, absolutely. And so that pivots us into hot, because in your book, a big part of, and the new book, which is not out in English yet, it's out in Danish. Is that the language that's written? Danish. Danish.
It's out in Danish. So if anybody knows how to read Danish, great. We'll link to it in the show notes, but it'll be out in America soon. It's called The Thermalist. But part of what you do, let's hope, knock on wood. I suspect so. So in this current book, Winter Swimming, which is available and you guys can pick it up, it's inside of the show notes, the link to it on Amazon here in the US and Canada, etc., all the places. You have a whole section that also talks about sauna and heat. Now, I wanted to start off big picture. Why do you think that there's just so much more of the literature that's out there on heat compared to cold? Is that just because human beings as a whole are probably practicing more heat exposure than cold? So just the natural interest that got researchers like yourself wanting to look at it was just a little lower?
I think that, like we talked about earlier, on the cold has had this little bit of a dark shadow over it in history, and the heat not so much. And we have good long cohort studies from Finland showing really nice long-term results on what happens in your body, on health outcomes after 20 years going into saunas. So I think
that's the cohort studies that you're talking about.
That is the Finnish cohort studies, exactly. And so it's more studied than cold exposure, and I think it should be more popular out in the world doing saunas, because it mimics actually training and workout, like you go to the gym. So you can mimic a training session going into the sauna. And I think this is really not that you should not then train, but I think it's very important to say, well, if you for some reason are not able maybe to go to the gym, then you will also get this cardiovascular workout by going into the heat. You will have an increase in nitric oxide in your blood vessels, which will help your body deliver oxygen better around all your cells in your body. And you will also have this increase in endothelial cells in your blood vessels, which will help your cardiovascular system to circulate the blood even better. And it has and that is just what happens in your body, right? But it also decreases your risk of cardiovascular diseases on a long term, and that is what these long-term observational studies have found. And I think it's a really good observational study that we are referring to here. So I think it's really good because these Laukanian and colleagues from Finland published this paper from 2015, where they showed that if you go into the saunas 2 to 3 times per week, you will lower your risk of premature death. So lowering your all-cause mortality by 27%. And if you go every day, so 4 to 7 times per week, you will decrease it by 40%.
Which is huge.
Right? There's
not many. What do we know of that is in that similar boat in terms of
Exactly.
lifestyle therapeutics.
Exactly. And this is just doing this from more than 1 time per week. So the control group, and I think this is important, the control group were also sauna bathers. So meaning that they also choose this lifestyle of using the sauna. And I mean, you could have a control group which didn't do it at all, and then you can maybe debate then what happens if you just do it. So they really showed a dose response relationship in doing
at those dosages.
At those dosages. So at more than 2 times, up to 7 times is healthy for you if you don't overdo it. So what I also think is very important here is how long do you sit in the sauna?
Right.
Yeah. So they showed that up to 19 to 30 minutes at a time at 80 degrees Celsius. How do we convert that?
What's 80 degrees Celsius? I think it's 120,
176, I think.
Yeah, 176.
Yes. So I think the important thing is that when you go into the sauna, that you don't overdo it. So
Right.
19 to 30 minutes seems to be the highest threshold for getting the health benefits on a long term, and so you don't overdo it. So at 80 degrees Celsius, which is 176 degrees Fahrenheit, is usually what they do in these Finnish saunas. And they showed also that when you then reach the 30 minutes per session, you kind of have like a plateau in risk of cardiovascular diseases, that then it starts to increase a bit again. So these are the outcomes of cardiovascular disease and also all-cause mortality. So it seems like within this window of up to 19 minutes per time, 30 minutes, if you stretch it a little bit, but you won't get more benefits from
staying longer.
And that also, I really think that showed that it is the micro-stressing, the short amount of stress that you put to your body that is going to make your cells more resilient, make the cells live longer, because you increase the heat shock proteins in the cells, which will repair the cells, repair the proteins in your cells to live longer. So, and when you then overdo it, you exhaust the cells. And this is referring again to this, Hans Seeley, the scientist who discovered the stress syndrome. So I really think this all collectively shows that what happens acutely when you expose your body to acute stress, but also on the long term, there seems to be a higher threshold for when then the risk of cardiovascular diseases increase after 30 minutes. That's going to show when your body gets exhausted. Your cells get exhausted.
In the US, we have this children's book. I don't know if you guys have it there too. It's pretty popular. It's Goldilocks, right?
Oh, yeah.
And the Three Bears.
Yeah.
And so we have this, this term, the Goldilocks zone. Not too hot, not too cold, just right.
Yeah.
Right? Just right for you.
Exactly.
And again, you covered that with cold. 11 minutes of total cold exposure in a week, the benefits starting at 59 degrees Fahrenheit, and those cold exposure broken off into 2 or 3, sessions that would be there in the week. And also making sure, Søberg principle, drying off on your own and not immediately returning the heat. And here we have it now with hot too. And I believe it was, you wrote about it as being 57 minutes of total time in the week.
Yes.
Right? And that would be, in these up to 19-minute sort of sessions, 19 to 25 minutes, 19 to 30
so it's
minutes.
57 minutes per week of heat exposure. You can do that in a sauna. That's what it's tested on, at least. And then divided that onto 2 to 3 times per week with 2 sessions each. Or you can just figure out your way of doing this. But 10 to 15 minutes is what my subjects did in this study. So it really, I think it corresponds quite well with the Finnish sauna study, where they have shown that it's beneficial up to especially 19 minutes, and up to 30 minutes is okay. But you don't have to overdo it. You don't have to.
Don't overdo it. In fact,
do
you may
more. Less is more,
be
right?
harmed if you overdo it.
Yeah, exactly.
Which is important, especially in America. As you're going on all these American podcasts, there's a sense of bravado and challenging each other and doing things like that. So it's good to just remind people, don't overdo it, right? Just getting the basics is good enough. Yeah. That's inside of there. The other thing that you've noticed also too, or that you've talked about, is that brown fat is also activated by heat. But how is it different than in cold? And is it less so in heat than in cold? Do we know right now?
We don't have the answers to all those questions.
Okay, got it.
But we do know that it gets activated by heat. There is a cell metabolism study showing that that cells who are exposed to brown fat cells who are exposed to heat also get activated. So, and I think it really makes sense that we that our brown fat is a temperature regulator in our body more than just a cold regulator. So it's there to keep us warm, right? Yeah, when we are cold. But it's also to regulate us when we get too hot. So it's kind of like counterintuitive. And now when you told me you are from India, you know that in India, when you are warm, at least I've been told when I went and visit my family in Sri Lanka, they said that, well, if you're too hot, then you'll have a tea. And I was like, when I was a child, I was like, this is crazy. This is counterintuitive. Why are they giving me tea? Then I'll burn up from the inside.
Right.
But it really makes sense when I think about it, because when you then increase your brown fat and you increase your temperature inside your body, you will help your body open your blood vessels and you will increase your sweat rate. So it helps your body to get rid of the heat. So the brown fat is it's very clever in a way. It's just regulating our temperature in the body. So it makes sense that it also activates in the heat.
Is there any truth, you mentioned India, right? One of the things in Ayurvedic tradition that you talk about, grandparents, my grandparents sometimes when I was younger say, don't drink. There's all these different, ideas that people have. They would tell us like, it's better to drink room temperature water. And again, I don't know if there's any studies on this, but just your thoughts versus like drinking ice water, right? Because we don't want to make our system too cold. But I think that our system is so much more resilient than we give it credit for. And who knows, maybe that was passed down from somebody or another. But in general, I think our body, obviously you don't want too hot of a tea, right? That's something that can burn you that can cause situation. But it sounds like our body is so much more resilient. So having some cold, having some hot, it's like, it's all good.
It's all good. As long as you don't overdo it. I mean, that is going to challenge your cells and challenge your nervous system. And that is what you really want to do, because we were involved in this. So it does really make sense that it's also helping us keeping ourselves healthy. And our body wants to be in that balance. So I think that we should just learn to accept that. And it's going to take a while for people to notice this, also doctors, and to see that there's actually literature around this at this point, and more is coming, I'm pretty sure.
What I'm excited about for the future is, and people building on top of the research and the work that you've done, is I'm excited for people now, at least in the US, we don't mandate through the FDA, the Food and Drug Administration, we don't mandate that popular drugs are tested against lifestyle components. So I'm very excited in the future for people to do studies. There have been some studies that have been done in diabetes, comparing, metformin, which is a very popular diabetes drug, compared to lifestyle interventions. There was one definitive study that was done that was highlighted in this book by Dr. John Abramson, who's a guest professor and lecturer at Harvard University, who has written a lot about some of the where clinical trials can go wrong in the pharmaceutical world because of incentives that get out of whack, right? And encouraged to sort of not look into lifestyle components. And so doctors only get one part of the narrative that this drug does X, but then again, nobody asks compared to what.
Yes.
Right. So I'm very excited for the future, which is, okay, how does this drug work compared to some intervention like cold exposure when it comes to something like insulin resistance, glucose tolerance, and other aspects? Can you see a future where this is all coming? It'll take time, but can you imagine that?
It would take some time, but it's coming. And I think that it was last year there was published this amazing paper where they have tested physical activity against different also drugs, and it actually showed up that the physical activity protocol was actually more beneficial and more healthy than all these drugs. So I think that and this was the study that's really amazing, right? And putting prevention medicine in front, but nobody talked about it. It's like, it's not really something that is promoted in any way. So I also think that we need a paradigm shift in this. We need to focus more on how to stay healthy. How do we help people get aware of how does the body function? Also, we need to know all this, because we need to teach our children how to change this crisis, right? It starts with us, the adults, but we have to learn this and accept that we can't fight this off with more drugs, because we have been making more drugs for many years now, and the crisis is still increasing. So we need to make a change. We need to think about health in another way, so people can start to like engage more into how does my body actually function? How can I help myself keep myself healthy? And that is a hard work. Of course, it's hard. It's hard to be alive, and it's hard to stay healthy and alive, right? So, but we need to teach people how to do this. But the word will come out, and I think that in the future we will have more of this. I hope that there will be this shift, so we also get more funding for this kind of research. I know for my research, I had to fight a lot of years to get the funding for my study. 6 years took my PhD. It took 6 years, so it's a lot of time compared to my colleagues who did a PhD in 3 years. So, and that is because it's very difficult to get funding into the preventive medicine. But I hope that it will come in the future.
Yeah, we need it more than ever.
Yeah,
we need it more than ever. A few more things that I have while I have you here that I wanted to kind of go through, if that's okay. And if you need to take a break at any time, you let me know. When you're traveling, right now you're in Los Angeles, you're here to do some podcasts and connect and promote the book and your work and your research, which we're so thankful of. Do you have any tips for people when they're traveling, like on your trip here to LA? Will you try to have some cold exposure? And if so, are there any practical tips that you have for people that are looking to maintain it as they travel?
Oh, I must say that I'm one of those people who always get very jet lagged. Yeah, I think I have like a very strong circadian rhythm. Doesn't want to change. It's like very like in my clock. I don't want to change so in Denmark we are 9 hours ahead of LA time now. So I probably should be sleeping very soon if I was in Denmark. But I think that doing a cold shower in the morning when you're supposed to be awake at that time zone, that's gonna help change your circadian clock. So by increasing that cortisol and also norepinephrine, it's gonna change it a little bit faster. So what I did is there was a pool up on the rooftop where I live at my hotel, and it was closed.
It was closed?
Yeah.
Okay, got it.
But then I just asked, can you open the gate in the morning? Because I wake up at 6 or 7 here. And they agreed to, but they did look at me a little bit funny, like it's very cold in the morning here at 7 o'clock. I was like, that's the point. I was like, that's the point. Just open the gate so I can take a plunge. And so I did. And it definitely helped me. And I could just wait a little bit with the coffee. So cold is definitely something that could change your clock if you want to.
Yeah, and it may take a little effort, or you might have to ask nicely. But if you do that, you can figure out places.
Yeah.
What do you think about, sometimes I don't have access to my cold plunge. Right now is one of those moments, and I'll do cryotherapy, which again, just to put on the record, it's expensive. Typically, it's not accessible to a lot of people. And for those that are not familiar, it's basically you're walking into almost like a refrigerator type style unit, and they're using nitrogen gas to essentially like chill the air. And so you're walking into air that's usually around like negative 170 or 200. It has to get, the air chill has to be a lot colder for you to feel it. And then typically you can stay inside for, usually it's like up to like 3.5 minutes that are there. Most of the research that's out there is on submersion. It's not on these things like cryotherapy. But what do you think about people using that as a tool if they have access to that?
Yeah, if people have access to that, and I think that it could be something that we should also have some more literature around that. I think you also just mentioned that we don't have much science on this yet. Definitely not on the long term. What is this beneficial for? Is it in any way different from submerging yourself into cold water? But what I think is interesting here is some studies on the skin. So it's like if you have eczema, for example, is it called that?
Eczema, yep.
Eczema, yeah. These studies show that you will have an increase in elastatin. Is it
Elastatin?
Yeah. Okay. Good. Looking for the words. Sorry. And also it makes the skin more moist. And if you have eczema, it seems that it's less itchy, the skin, and less red. in these subjects, and this is tested in children, and also not in children, in adults. So I was just
So doing cryotherapy could be beneficial for some people with eczema based on that study?
Yes.
Okay,
Yeah. And it seems like there is also some studies showing that you maybe have some less more youthful looking skin afterwards and less wrinkles, but it's not really, it's understudied, I think. Yeah. But there's a lot more claims out there on the internet than can be backed up with science, I think. But I think that when exposing your skin, which is the main thing, right, to cold, you will have some benefits. And I would suspect that you will have some benefits also on the long term, also maybe on the cardiovascular system, but we don't know yet. We have to look into that.
And really with your work, it's really, getting uncomfortably cold, right? And that is going to be a spectrum for people. If you're starting off, that could be splashing your face with water. If you're good with that, then you may be going to like a bath with a little bit of ice inside of it. If you're good with that, you might go to like a full-on, cold plunge, or you might do some winter swimming. But the goal is to get uncomfortably cold and to follow the protocol that you've laid out over there, right? Because that's what through your work and just what's available there, that's really going to target that brown fat, which seems to be where the majority of the benefits. So the question again with cryotherapy would be, maybe somebody can do some research and see, is brown fat activated in that same way?
Exactly. And I think that the fat loss, you can say, angle of this is that's very interesting, I think, because this is like the health crisis that we have is based on the inflammation. So if we can target the inflammation, that's gonna decrease early mortality in the future. And I think that there's actually a new study I just want to mention that because there's a new study from the Czech Republic showing that if you, and this is in soldiers, they have both men and women in this study, where they had 46 subjects divided into a control group and also an interventional group. And they did 1 cold water immersion per week and 5 cold showers. So the cold immersion was 1 to 2 minutes, and the cold showers were 30 seconds each and 5 times for 1 week. And they saw after 8 weeks that there was actually a significant increase in fat loss in the intervention group, and also they got a lower waist circumference. So I really think that if you don't overeat, of course, this is also about calorie intake, right? So this was very controlled in this study, and that's why I think it's really good. It's from the Czech Republic and published this year. I think that it can actually we can measure this on and later outcome. So increasing the brown fat, increasing our metabolism, we should be able to see fat loss in the long run.
Was this the study that Andrew posted about recently?
Yes.
That was the one?
Yeah.
Tessa, can you bring up Andrew Huberman's Instagram just so we can have reference to it? Because I saw he also tagged you inside of there, and I think he was saying that this study is building on top of the work that you've started out.
They also ended on the cold.
Yeah, I thought that was really, really interesting because they're building on top of it. And that's how research is done. You do a first study, right? And you proof of concept, as you mentioned, which you struggled for years. Inside of the show notes, it was really interesting as I was preparing. You were like, asking me about why it took me so much longer to do my PhD than normal, right?
Please, but that is because I really want to like put out there that preventive medicine is
you have
really,
to fight for it.
You have to fight for it. It's understudied, and it's not put forward as something that we want in society, but there's it's skewed here because society really wants this, I think. Right. But the funding is not really the focus in our politics maybe is not really there yet. But it's starting.
And who was your main funder? Was it like the equivalent of the National Institute of Health for Denmark, or who was the main person that gave you funding?
So who eventually ended up giving me my funding for my PhD.
If it's public, if I can ask.
It is. It's always public, who funds who. And that was the Novo Nordisk Foundation.
What was foundation?
Novo Nordisk Foundation.
Okay.
So
Novo Nordisk. The medical company.
The medical company, but it's not the same as the foundation.
The foundation.
It's something different from that. But they supported this. And I really think that is amazing. And I'm very grateful that they did, because
That's
it was
amazing.
just at the end, I was like, oh my God, this has taken 2.5 years of just sending an application out and another one and just rejection upon rejection. It was just so many. I think I was stressed at the end of that.
Totally, I can imagine.
And then a week or two later, after I told my supervisor, I can't continue like this. I almost did a PhD before my PhD, and they agreed that it was not really good, and we need to think about how we write these applications. And of course, we have done that. We have rewritten everything, but then I finally got it, and I was so happy.
And even for just again, because I think there's a lot of people who are listening here who are in healthcare. There's a lot of people who are listening who are in entrepreneurship, and they even think about like the system needs to change for, raising money for research, right? And you've created a whole institute, which I'd love to talk about as well. That's part of it. For even a small proof of concept study like this, but that is looking very deeply at a lot of markers, how much does something like that cost, right? Like how much would have that cost to even just do something like that? I'm just trying to give people a sense of that, these studies are quite an undertaking.
Yeah, it's millions of Danish kroner, so that's like it's hundreds of thousands of dollars. Yeah, so it's really, really expensive, also because when we do studies like this, we have to also, for example, do the PET MRI scanning,
right,
which is super expensive. It's hugely costly to do this kind of examination, which normal people don't have access to. So we cannot really measure any people's brown fat. And we also had the cooling system, which I used, and had to customize a lot of this kind of gear that I was using, because I was also customizing how to measure muscle shivering. So together with an engineer, I studied the body on which muscles were shivering first when we get cold. And so, there was just a lot of things that people don't think maybe about, that it takes up like a lot of money to do all the blood sampling, and also staff. I had a whole group with me, some of them students, of course, and which I was tutoring during the day, but also we had to hire people to help also just be there to take all the blood samples, because we have to, of course, took a lot. We wanted to go deep with a few subjects instead of like going broad with a lot of subjects. So to do the concept, proof of concept.
Yeah. Well, I mean, since the studies come out there and there's been so much attention that's been placed on your work and literature, and I so appreciate researchers like yourself who write books and go on podcasts, which is not an easy thing to do, right? You have your normal life, you also have your family, you're married, you have kids, but to make time for these things, because it's really making the literature more accessible to people, right? But has all this momentum and being mentioned on Joe Rogan and other things, and of course, Andrew Huberman, who's one of your biggest champions, has it brought more attention to the Institute? And tell us a little bit more about the Institute and some of its goals.
I think that I'm so happy that I got mentioned on the Joe Rogan, and that was actually Professor Andrew Huberman who did that and talked about our research. And I'm so grateful for that, because that's really, I don't think that he at that time knew that one of my goals is to actually talk about this, and I really wanted to promote this and tell people what's going on and how to do this in a healthy way, and how maybe not to do it, and what is actually maybe the higher threshold for this, and so forth. So that kind of like helped me a lot to get also podcasts like here talking to you now, and I'm not really sure that would have happened if that he didn't really
totally.
I think that's really helped me a lot, definitely. I also have my books, of course, and that happened before that, but and it's out in 13 languages, winter swimming. But I think it really has helped me and put a lot of attention on also all the years that I have studied and what I know today. And the reason why I opened my institute, Søberg Institute, is because I see that a lot of people have many questions. How to do this right? How to do this healthy? How can I start this? And also, there's also a lot of people maybe doing it too much or doing it extremely. So it's always there when something new has started, right? A trend or something. Then you, of course, have people just go ahead and maybe overdo it a bit, like maybe with the sauna 30 minutes and then beyond that. So not to you can say, to teach people how to do this in a healthy way, how to get started. But also I think there's coaches out there and trainers instructors who would love to teach this in a healthy way. And we need this for the future to increase also preventive medicine and increase people knowledge around how can you stay healthy. And that is what I want to teach in Søberg Institute. So I have created a course there for the end user, so they can get started with this. It's a 21 days course. So both on breath work and cold and heat exposure, how to do this in very bite-sized videos that I have put out there.
It's very step-by-step.
Very step-by-step and layman language. Everybody can follow this, and already got really good reviews also. So I'm really happy that, because I've never done a course before, but I know how to talk to people about what is good and what is not so good.
Totally.
So I think that it was really important for me to put that course out. But the education is definitely also important for getting the knowledge out and getting people healthier. So I'm looking forward to do the education as well.
Yeah, it's fascinating, and I just love to see the trajectory and to see you shine. And you're also really good about putting out content on Instagram, and people can follow you over there.
Thank you.
So it's we have to make this practical. We have to make this exciting, right? It should be fun. Health should be fun to do. And in fact, that's a big through line through the winter swimming. Is like you talk about it. Sure, you can do it yourself, but a lot of people choose to do it in a group setting.
Yeah.
Because I've also found that if you're more likely to be accountable if your friends are also doing it as well.
Yeah.
Right? There's the big research from the Framingham studies.
Yeah.
Right? The Framingham cohort out of Massachusetts. And there was one on, for those that are not following, I've mentioned this before, but this is over, I think, like 50 years that they had been looking at these, at least the first cohort. So they've been extrapolating out the data and spinning it off and looking at all these endpoints that they've been measuring. And one of the endpoints is that if your best friend becomes obese or starts to head towards obesity, you're twice as more likely to head towards obesity yourself, even more than the influence if your husband or wife or child ends up heading towards obesity. And it just shows us the influence that our friends have on us. We're more likely to follow our friend's recommendation than our wife's recommendation or our husband's recommendation. I don't know if that's a good thing or bad thing, but we like to be liked by our friends. This is why I lived in New York City for a little while. If you're in New York, there's a big drinking culture that's there. So if everybody every night is going out to drink, just for even if you're just meeting up to talk a little bit about something, where in LA, it's a little bit more like, coffee in the morning or green juice, or there's a big culture in LA of hiking. Even for meetings, people will say, let's go on a hike for a while.
Walk and talk.
If everybody's doing that, then you're more likely to do it.
Exactly.
So I think doing this with other people is also a way to ensure that there's sustainability that's inside of it.
Yeah. There's another, I think, in what you're saying is also that, when looking for friends, then when you find friends, then also look for healthy friends. If you want to be healthy, then be around healthy people. It's really something that's going to affect you, right?
It's so true.
So and when you go winter swimming, you will be likely to do what they do, right? So if you want to winter swim, then maybe, or co-plunge, then find other people who do that, because they're going to motivate you. They're going to make sure that you also do it and tell you how they feel down the road, because they're already adapted maybe. So finding other people to mirror yourself in is very important. I think that. There
was one random thing that you had brought up in one of your interviews, and I was actually curious to ask you about that. Is you actually found there was kind of one individual in your group that didn't have any brown fat.
Oh, yeah.
Right?
Yeah.
I thought that was, okay, what's going on with that person? Because again, this is a young male.
Yeah.
Right? Was he too lean that he hadn't had brown fat? Do you know what led to him not having brown fat? And was he able to get more brown fat later on by practicing this protocol? What did you find?
So he was a winter swimmer, and I think that was the most surprising thing about this.
Okay, got it.
Yeah.
So he was just a sort of outlier in a way.
He was an outlier, and he was what is in the paper we called the subject, because we have to label them a little bit, and that's normally not what you do with people. But he was like a person with no brown fat, so a brown fat negative. So, and we know that from other studies before mine that some people don't have brown fat, so just on a genetic level. So you cannot really increase the brown fat if you don't have it. So there's going to be some percentages, which I don't know what that is, but there's going to be some people who really don't have that. And what I observed in him was that he could not tolerate the cold at all, even though he was adapted in other physiological parameters, which is like vasoconstriction, and also he of course got all the metabolism going, but from the muscles, and that was way earlier than the other subjects. So when I cooled him, he started to shiver way before he should, or I expected him to do, compared to the other subjects. So he was definitely more difficult for me to control in the laboratory setting, where I was cooling them for 3 hours. Mild cooling, it was called, but eventually they got really cold. Yeah, that's how we do it. It sounds a bit brutal. Yeah, they volunteered. But he really, really wanted to be part of the study. And he was also a winter swimmer, and he loved it. And I think that it also kept him warmer, because he increased the metabolism in his muscles. But when we did the PET-CT scanning, and I was already a little bit like awake when we went to the PET-CT scanning with him, I was like, that was difficult to control. I was really working hard for this one. And then we scanned him, and I thought that was a mistake. So there was no brown fat. And I was like, can you just scan him again? Look through them. I don't understand. Should we redo the study, or what happened? And then the PET-CT department, the doctors who were also part of the study from Copenhagen, Rigshospitalet, the Copenhagen hospital, they analyzed the pictures again and found that there was just no brown fat, even though he was cold enough and he was not shivering at the point where we scanned him. But he did shiver a bit when we were in the laboratory, just testing and cooling him down. But I had to have him at a higher degree of temperature than all the others. So if you don't have any brown fat, you could probably...
Which is not going to be most people, right?
It's not going to be most people. It's an outlier. It's definitely an outlier, but it really shows that the rest of the winter swimmer group had a higher resilience. Absolutely. They didn't shiver. Absolutely not. Compared to the control group. So this winter swimmer were very much more alike the control group when it comes to shivering and also his metabolism. So that was kind of like a little bit of a proof of a concept in the study also, that I could see that his metabolism were more like the control group, and he didn't have that insulin sensitivity like the winter swimmers did, and he didn't have the fast glucose clearance as the rest of the winter swimmers. But this is based on N1, right? So it's really not something that I can say is going to be...
You can't say too much about it, and it's not going to apply to most people, but it was just interesting that it happened.
It's an interesting observation. Sometimes we call this a case study. So it could lead to other studies, and that's why it could be interesting. Also good to talk about it.
Yeah, absolutely. But again, most people are going to have some brown fat, and most people can get better through cold exposure, deliberate cold exposure, and of course, some heat exposure too, if they want to, inside of that protocol that you had in your study, which is going to allow them not only to get a little bit more brown fat, like have you measured like how much more brown fat people, because it's not just about adding brown fat, it's about activating brown fat. Is that right?
It's activating. Yeah.
Activating it. Can you actually grow the amount of brown fat that you have in your body too?
Yeah, so this has been studied also in rodent studies, but it's also studied in humans. So exposing yourself to cold, even cold air temperature, you can increase the amount of brown fat that you have, so the volume.
Right.
But you can also increase the efficiency of the brown fat cells, which I think was mostly what we saw with our winter swimmers in my study. So it seems that if we measured the volume of the brown fat in the winter swimmers compared to the control group, they didn't have more volume of the brown fat, but it was more efficient at heating up. So more activation of the mitochondria in the cell will then increase the temperature. And that's going to increase your metabolism and your thermogenesis. So we saw that they were warmer. And this is one of the, I think, main outcomes of this study is that you will have more efficient brown fat, and you will have increased metabolism, but also you will be physically warmer.
Yeah, and who doesn't want that? And in the future, what would be some wish list of a few studies that you think that either you would want to build on or maybe somebody else to look at to see? I think you mentioned a little bit about, the weight loss component. Is that with also, a calorie component, because we have to watch out how many total calories we have?
Yeah.
Would you love to see a study of somebody doing to see like, can cold activation be part of the process of reducing body weight and improving body composition? Is that something that you'd love to see?
Absolutely. And I think that would be very interesting to follow in the future. I know that there are studies working on this, but I also think that the mental health component of this, is also a very interesting side of this. So it's not only the metabolism, but the metabolism is like the ground thing. I think when we can work on inflammation and we can decrease inflammation, you are working on your mental health at the same time, because inflammation increases the risk of neurological diseases, right? So Alzheimer's disease, depression, anxiety. So we know that if we can decrease inflammation in the body by activating, for example, the brown fat, then you will have a lower risk of those diseases as well. I think it would be very interesting not only to look at the preventive side, but also to see if we can even cure depression. Can we cure anxiety? Can we cure type 2 diabetes even? So not only from a preventive side, which I have been working on, so the basic science of this, but I hope that this could be like what do you call it, like a stepping stone,
right?
Yeah, to studies looking also to see if this can cure something. It's different. Physiology is different when you have a disease, right? So it's interesting to see if your metabolism will be activated enough, and if you can increase your insulin sensitivity once you have diabetes and just exposing yourself to cold. And what protocol should you use? Is it more, or is it, it's probably more, or is it the same? Is that enough? So there are many questions for a lot of years of research.
Yes, a lot of years of research, a beautiful career on top of what's already been established. And partly one thing that I'm really interested that I would hope in the future is that because funding is so hard to come across for researchers like yourself, I would love to see more, crowdfunding. That's there, right?
Yeah.
You see, actually, do you know the podcaster Tim Ferriss?
Yeah.
The Tim Ferriss Show?
Yeah.
He's done this a little bit with the psilocybin research, right?
Yeah.
And some of the work on Dr. Roland Griffiths.
Yeah.
And I believe it's Tim Ferriss's foundation is called the Sensei Foundation. But Dr. Griffiths, who unfortunately right now actually has terminal cancer, I believe. But he's been on this podcast before, and he was one of the early sort of researchers in this more modern stage talking about the benefits of psilocybin. But it was amazing to see that the community, the people who are following you on Instagram, following me, following Andrew and Dr. Rangan Chatterjee and all these individuals, they want to see more of this research. So is there a way for them to get involved in the funding? And I'd love to see, maybe you guys come up with it. I'd love to share it with my audience, some sense of crowdfunding so we can get more of this literature out there from teams like yours. That'd be really exciting.
Yeah, that is definitely something that I'm thinking about in to do, actually. So that would be very interesting.
Well, keep us posted on it. Dr. Søberg, this has been fascinating. I so appreciate you coming on the podcast and chatting about your work, sharing all the knowledge that you've had, talking about your excitement and enthusiasm for the space as truly a lower cost tool, no cost tool, something that's accessible to pretty much anybody around the world, and that you could experience the benefits of cold immersion, especially not just right away, but that there's done right within this protocol that we've outlined here inside of this interview and that you've outlined in your book, that there's all these long-term benefits as well. So I just really acknowledge you. And I thank you for not quitting on your PhD.
Thank you.
and sticking it out. Yeah. And I hope the world continues to reward you with all the attention that your work deserves. Let's just share again with people, if they want to do the course, if they want to learn more about your work, what website should they go to?
Oh, they should go to my institute, which is soberginstitute.com. That is SOEBERG institute.com. There you can find the 3-week course. And also, I think we should give your audience
Yeah, I think we have a special link inside of the show notes we can put inside of there.
Yeah, so
and we'll put it on YouTube for those of you that are watching.
Oh, fantastic!
And they can sign up for the course and do it there. Yeah. And then, of course, where books are sold, they can pick up Winter Swimming. Here's the book right here. I've marked it up a bunch inside. I got to ask you to sign it afterwards.
I will.
Winter Swimming, you can pick it up. You said it's in 14 languages that are out there.
Yeah, 13. I think
13
it's
languages.
Yeah.
And then a new book, hopefully coming out in the future, but that's available in Danish, and it's called The Thermalist. Wait, just briefly share with us, what does that book build on top of that this book started?
So Winter Swimming is, you can call it maybe an introduction to my research, which is coming in The Thermalist. Winter Swimming is background literature, the history, what is brown fat, it's everything we just talked about, also sauna. So everything we just talked about is in Winter Swimming. The Thermalist is a book where I dig deeper in some areas around the cold and the heat, and very much about stress. So the book is mostly about the healthy stress, how can you use cold and heat and breathing. So it's another component that I put in there because that is what I used in my research, because the breathing is so important to lower stress. Also, when I did my studies, and I had to dig into that literature to make sure that I was doing that right. So I also put that into my new book. There will also be my results, and it's going to be interviews from different professors around the world. Also, Andrew Huberman. There's a bite of our interview from an Instagram live that we did more than a year ago now. And there's case studies and interviews with addicts and also other people. I have been around the world with this book because it took me 2.5 years to write, and I started right after Winter Swimming. So Winter Swimming is like the beginning of all this research, and I think that they complement each other, but they are definitely different books. So yeah, I would encourage people to read both if they are very interested.
Well, when it's available in English, I'm excited to read it.
Yeah, it's going to take a while, so why not just dig into Winter Swimming?
Totally, that's a great place to start. Thank you so much for coming on the podcast. I appreciate you being here. And again, thank you for all your work.
Thank you so much for having me.
Hey, YouTube, if you enjoyed what you just saw, keep watching for more great content on how to improve your brain and your life.
It's all about recounting the event, but trying to uncouple the event from the negative emotion and the feeling of agitation. It's about really being able to get close, right up, in front of you, your face.